Hello, beautiful people. I'm so glad that you are here. Welcome to my course, Linux and Network Administration. Now, this is a part where you're going to learn everything about the operating system network administration. In this course, you're going to learn what is a DHCP, what is a static IP, how you could assign those static IP, how you could do NIC bonding, and many other things that you need to know when you're working in a corporate environment. My name is Imran Afzal, and I've been in IT since 2000. I have been teaching thousands and thousands of students worldwide. I have helped so many of my students getting a job of their dream. When I teach, I make sure you understand every single concept of that topic. I actually graduated from Baruch College, City University of New York, and my concentration was computers information systems. I did my master's in business administration from New York Institute of Technology. I have worked for Fortune 500 companies in New York City. So, all I'm telling you, once you're going to take my course, at the end of the course, you're going to learn everything you need to know about that specific topic. So, what are you waiting for? Let's go ahead and enroll. Hello, folks, and welcome to our course overview for the course Linux and Network Administration. Please do spend a few minutes with me to go over what are we going to cover exactly in this course. So the very first thing is section 1, introduction and course overview. Introduction, I have already gone through. I have given you my background, the courses that I teach, and a quick introduction of this course itself. Now about the course overview, which I'm doing right now. And you will have the option to download the syllabus at the end of this video. Then you have section 2 for lab setup. If you have already a Linux machine running, then you could skip this video, but I would skip this entire section, I meant to say, but I would highly recommend that you do go through the Linux installation so you have a better understanding how to install and configure Linux, especially CentOS. What I'm covering in this entire section is how we could download and install Oracle VirtualBox. VirtualBox is a software that allows you to run multiple virtual machines on a single host or a single hardware. Then we're going to create a first virtual machine and do the Linux installation. And for the Linux installation, as I said before, I have covered CentOS installation. If you wanted to go with a different flavor, that is perfectly fine, but I would recommend you to stick with CentOS. Then the actual content, then the fun begins on section 3, where we're going to cover the actual network administration on Linux. We're going to cover how we could enable internet on a Linux machine, the network components, what are and what should we know what that are the components of a network. We'll cover network files and commands, the NIC information. NIC stands for Network Information Card, and we could cover how we could pull information of the NIC. We'll cover the NIC bonding, meaning one NIC and then you have a second NIC. You could actually put them together to create a redundancy. So we'll cover that in this video. We'll go through the downloading files and applications. I want to cover curl and ping commands, which will help you connect to other machines. Also file transfer commands like SCP, which is a secure copy protocol, rsync for remote synchronization. I also wanted to cover the difference between SSH and Telnet, which one should you use and which one is more secure. Hostname and IP lookup. Then moving on to the network time protocol, NTP in short, which allows you to synchronize your Linux machine, a client, to a server for the time synchronization. I also wanted to cover the newer version or newer package of NTP, which is cronED, which is also a time protocol. Then we'll go into the tracing the network traffic like traceroute, etc. In this course, I have also covered or added some of the homework that I want you to do, and I want you to read the handouts as well. Good luck. I'll see you in the next lecture. In this lecture, we will talk about something very basic and equally important, We will begin by understanding what basically a network is. So let's begin. Every day we use our phones, laptops, and TV to connect to the internet, right? The phone joins Wi Fi on its own. The laptop gets files and information from website, and the TV shows us programs from online streaming platforms. It looks easy, but there is a system working in the background. This system helps all devices share data and stay connected without problems. This is called a network. Technically speaking, a network is just a connection between two or more devices, like computers, phones, printers, that lets them share data, resources, and services. So if those devices can talk to one another, they are part of a network. Well, not all smart devices connect in the same way. Some use cables for connection, and this is called a wired connection. Others connect without cables using Wi Fi or Bluetooth, and those are called the wireless connection. Whether the connection is wired or wireless, it doesn't really matter. What matters is that data being shared between devices so they can work together. Let me give you an example. Imagine you are relaxing at home. Your phone automatically connects to Wi Fi, your laptop joins the same network. The smart TV begins streaming your favorite shows, and the printer starts printing without even needing a cable. So these devices are not just using the internet, they are communicating and working together. This is basically called home network. This idea is not limited to your house. In offices, networks help employees share files and printers. In schools, they connect computer labs and allow access to learning tools. In banks, networks make sure ATMs and branch systems talk to central servers. In hospitals, doctors use them to view patient records from different rooms. Even in cafes, public Wi Fi connects customers while keeping their connections safe and separate. Now, let me take you back to where networks started. Back in the late 1960s, researchers created something called ARPANET, which stands for Advanced Research Projects Agency Network. Computers back then could not talk to each other. ARPANET changed that. It was the first major step toward digital communication, connecting computers through telephone lines so data could be shared between locations. Then in 1970s, something called TCP/IP was developed. These are communication rules that tell devices how to send and receive information over a network. TCP stands for Transmission Control Protocol, and IP stands for Internet Protocol. Don't worry too much about the technical side. We will explore TCP/IP properly in our next lectures. For now, just know that it is the foundation of how the internet works today. As time went on, network grew. Offices set up local networks. The internet expanded. Also, people began sending emails, visiting websites, and working online. And this happened all through different type of networks. Let's talk about a few of those networks. The first one is PAN, which stands for Personal Area Network. It's very small. Let's say your phone connecting to your Bluetooth headset is a simple good example. Then there is LAN, which is in short for Local Area Network. This is the kind you find in homes, offices, or schools where all connected devices are nearby or close. Then there is WAN, which is in short for Wide Area Network, which connects networks over longer distances, like when different branches of a company are connected. There's also a term called MAN, which stands for Metropolitan Area Network, which connects parts of a city, like public Wi Fi across train stations. Well, there is another term that universities often use called Campus Area Network, or CAN, to connect their buildings. Also, in data centers, a SAN, or Storage Area Network, allows servers to share storage quickly and securely. So just remember that networks exist in many forms, but their job is always the same to connect devices so they can work together. Now let's talk about what makes a good network. If you're building one, it should be reliable. The devices should stay connected without random problems. It should also be secure, so only authorized people can use it. It should be flexible and ready to grow when more users join. And most importantly, it should be easy to manage so you can monitor performance and fix issues. This is exactly what we will learn in this course. Not just the networking meaning, but how to create real networks step by step and how to manage them like a professional. So, in our next lecture, we'll discover why networks are so important, from homes filled with smart devices to busy hospitals saving lives and even global companies managing operation across continents. Network is behind the scene that is making it all possible. In this lecture, we will talk about why networks are important, why we need them, and what makes them effective. So let's begin. We are living in a connected world, right? Everything from sending a WhatsApp message to accessing your bank account runs on some kind of network. But what if we did not have networks at all? Let's imagine an office with no network. So every computer works in isolation. In this case, if someone wants to print a file, they must transfer it using USB. If they want to send an email, they will need separate internet setup for each device. There is no shared access, no resource pooling, and no collaboration. Everything would feel slow, frustrating, and disconnected. Nothing flows, and progress takes much longer. Now compare that to a networked setup. All the devices share internet through a router, so files move instantly between employees. Everyone uses the same printer, cloud storage, and communication tools. It is smoother, faster, and more intelligent. Well, don't bother. We will cover routers in detail in our later sections. Just imagine it as a device that is used to connect two different networks together. This is the power of a network because it connects everything together and removes frictions. All right, so let's understand why we need networks in the first place. One major reason is resource sharing. Instead of buying individual printers for every employee, a network lets everyone use one central printer connected to the network. Same goes for the internet, storage, and specialized software. Resources are centralized, and access is controlled that would save time and money. Another benefit is remote access. Imagine a team working from home or different cities. A network makes it possible to access files, servers, or data from anywhere. Whether you are in the office or halfway across the world, the network brings it all together. All right, then there is a communication. So, from video calls to emails to internal messages, networks allow people to stay in touch instantly. In hospitals, that might be sharing patient data. In schools, it could be sending out assignments. In retail, it is updating inventory across stores. No matter what the industry, communication depends solely on the network. So, network also helps with collaboration. Teams can work together in real time even if they are spread out. They can share calendars, documents, and apps. It keeps everyone on the same page. And let's not forget security and control. A network doesn't just connect devices, it helps manage them. IT teams can monitor performance, control access, spot problems, and prevent attacks. Without a central system, things would be difficult. With a network, everything becomes easier to protect and maintain. All right, so what makes a good network? Great question. We understand the need for network. Now, let's look at what makes a good one. A good network is not just one getting things connected, it is about how well those connections work. First comes the performance. The network should be fast and responsive. If someone sends a file, it should not take minutes to arrive. Speed really matters here. The time it takes for a message to travel is called transit time, and the time it takes to get a reply called response time. Good design and strong hardware make a big difference here and make communication smoother and faster. All right, next one, when we are talking about the good network, we'll talk about reliability. A reliable network stays up and running even when things get busy. It handles traffic, resists failure, and recovers quickly. So if a cable breaks or a device crashes, the network should be able to reroute or fix itself. This is especially important in places like hospitals, banks, and government systems where downtime isn't an option. All right, then we have security. Protecting data is critical. A good network keeps out unauthorized users, block malware, and prevents data leaks. That might involve firewalls, password policies, encryptions, or even intrusion detection systems. We will explore all these tools in the security section. Scalability is another key factor. What starts with 5 users may grow into 500. A strong network can handle that growth without becoming unstable. That's where things like subnetting, VLANs, and proper planning comes into play. All right, finally, manageability. Well, a network that is hard to control becomes a problem. So admins should be able to monitor traffic, apply changes, fix issues, and update software easily. We can say the more manageable our network, the easier it is to keep everything running smoothly, right? So, what we understand today is that networks are not just technical systems, they are essential tools that power our lives. They help us share, connect, protect, and grow. And as a future network engineer, your job will be to create systems that don't just work, but work well. We will use the right devices, follow strong designs, and build networks that meet the needs of real people. In the next lecture, we'll start exploring the actual devices that make networks work. We'll talk about NICs, switches, routers, and understand what role each one plays in the network. In the previous lecture, we studied the TCP/IP model and how it organizes network communication into layers. Each layer performs a specific function, and together they allow data to travel from one device to another across a network. In this lecture, we will examine how a message is prepared for transmission and how it is processed when received. This process is called encapsulation when sending and de-encapsulation when receiving. We will learn how each layer adds or removes information to help the message reach its destination. Let's begin with a basic scenario. A user opens a web browser and requests a web page. The browser creates a message that needs to be sent to a web server. This message passes through the layers of the TCP/IP model. At each layer, specific information is added to help with delivery, routing, and error checking. This added information is called a header. In some cases, a trailer is also added. The message becomes a structured unit of data that can be transmitted across the network. So, at the application layer, the browser generates the request. This is the original data without any networking headers. It is passed to the transport layer where the TCP protocol adds a header. This header includes source and destination port numbers, sequence numbers, and control flags. The result is called a segment. The segment helps the receiving device understand how to reassemble the data and which application should handle it. Next, the segment is passed to the internet layer. Here, the IP protocol adds another header. This header includes source and destination IP addresses and other routing information. The result is called a packet. The packet allows the message to be forwarded across multiple networks. Although we are mentioning IP addresses here, we will explain them in detail in future lectures. For now, understand that IP addresses help identify devices across different networks. The packet is then passed to the network access layer. This layer prepares the packet for transmission on the local network. It adds a header and a trailer to create a frame. The header includes source and destination MAC addresses, which identify devices on the same local network. The trailer includes a frame check sequence, which helps detect errors during transmission. Since we have already discussed MAC addresses in earlier lectures, you should be familiar
with their role in local delivery. Finally, the frame is passed to the physical layer, where it is converted into bits. These bits are transmitted as electrical signals or wireless signals, depending on the medium. The message is now ready to travel across the network. As the frame moves through the network, it may pass through switches and routers. A switch reads the destination MAC address and forwards the frame to the correct device within the local network. A router reads the IP packet and decides how to forward it to the next network. At each router, the frame is removed and replaced, but the packet remains mostly unchanged. This continues until the packet reaches the destination network. When the packet arrives at the destination device, the process is reversed. The network access layer removes the frame header and trailer. The internet layer removes the IP header. The transport layer removes the TCP header. Finally, the application layer receives the original data and processes the request. Each layer in the TCP/IP model uses a specific name for the data unit it handles. At the application layer, the data is simply called data. At the transport layer, it becomes a segment when using TCP or a datagram when using UDP. At the internet layer, it is referred to as a packet. At the network access layer, it is called a frame. And at the physical layer, it is represented as bits. These names help identify where a problem might occur during transmission. For example, if a frame is dropped but the packet is intact, the issue is likely at the network access layer. To summarize, encapsulation is the process of adding headers and trailers to data as it moves down the layers for transmission. De-encapsulation is the process of removing those headers and trailers as the data moves up the layers at the receiving end. This structured approach ensures that data is delivered accurately and efficiently across networks. In the next lecture, we will study how TCP establishes a reliable connection between devices. We will explain the three-step process known as the three-way handshake and how TCP uses sequence numbers and acknowledgments to ensure complete and ordered delivery. Before we explore IP addressing and port numbers in detail, we will dedicate full lectures to those topics to ensure complete understanding.
In this lecture, we are going to cover the Oracle VirtualBox. We will go through the download and the installation of VirtualBox. Now, as I said previously, the Oracle VirtualBox is is a virtual environment which allows you to run a multiple operating system on the same hardware. There are other virtual platform that is available out there that you could use. You don't have to go with VirtualBox if you don't like it. You could use VMware Player Workstation, as well as other open source virtual environment. But anyway, I would prefer if you stick with Oracle VirtualBox, so this way we could go through the course together. Alright, so I will go open up my Firefox browser so I could download the VirtualBox software. You could use any browser you like. Then I'm going to the Google page, and in the Google page, I'm searching for Oracle VirtualBox. When you click on it, you're going to see the first link as Oracle VM VirtualBox. So you could click on it and then go to download, or you could go straight to the download page. Alright, on the download page, you're going to see the section where it says VirtualBox version platform packages. Now, depending on when you are downloading this VirtualBox, the version will be higher, maybe 1, 2, or whichever the version at that time you're downloading. It doesn't matter. Don't be confused. Oh, the one I am showing you is 6.0 and the one you are seeing is a different version. Basically, what we want at the end is a virtual platform that we could run our guest instances or guest operating system on it. Anyway, if you are using the Windows as your main host wherever you will run the Linux CentOS as a VM, then pick Windows host. If you are using OS X host, meaning if you are using Apple, then you could use this one. For Linux, for Solaris, for other operating systems, you could pick depending on your requirement of your actual operating system. Go ahead and click on Windows host because I am running Windows host, and that's where I'm going to run my VirtualBox. Now here it is asking me to save the file, and you could click, but I'm not going to click to save the file because I have already saved it to save some time. So if you have not saved it previously, so go ahead and click on this, and it will ask you to the location to save it. So I'm going to cancel it since, as I said, I have already saved it. Alright, I have my VirtualBox executable saved on my desktop, and here is the executable. All I have to do is go ahead and double click so it could start the installation. So once you double click on it, it will ask you, do you want to run this file? Click on run. Okay, now the wizard has started. It says welcome to the Oracle VM VirtualBox 6.0.14 setup wizard. The setup wizard will install Oracle VM VirtualBox on your computer. Click next to continue or cancel to exit the setup wizard. Go ahead and click next. Select the way you want features to be installed. So by default, the VirtualBox application has been selected, and the other features that comes with it, I'm going to leave everything at default. And it also tells you the version installing the feature requires 227 megabyte that you should have on your disk. So go ahead and click next. Please choose from the options below. Create start menu entry, create a shortcut on desktop, create a shortcut on quick launch bar, register file association. I like them all, leave them default, except I don't like create a shortcut in quick launch bar. So I'm going to uncheck it. Again, that's my preference. You could leave all of them selected. Click next. Network warning, network interface. Installing the Oracle VM VirtualBox networking feature will reset your network connection and temporarily disconnect you from the network. Proceed with installation. So that's fine. So make sure you are not connected to the internet, or if you are, make sure you're not doing any type of work that you will lose. So go ahead and click yes, and click install to begin the installation. Install. I am going to fast forward at this part because I don't want you to wait. I don't want to waste your time. So I'm going to just simply fast forward. Okay, so the Oracle VM VirtualBox installation is complete. Um, you can leave the check mark so it'll start it back up, and you could click on Finish. Congratulations, you have completed the download and the installation of Oracle VirtualBox. Now the next step is to create a test virtual machine, and then of course we will go ahead and do the actual operating system install on that virtual machine. Hello everyone, in this lecture we are going to create a virtual machine on our VirtualBox, the VirtualBox application that we have downloaded in the previous lecture, and now I'm going to show you how you could create a virtual machine. So I'm going to start up the VirtualBox. This is what I have it open already, and the version that I'm using for the VirtualBox is when you go to help and click on about VirtualBox is VirtualBox 6.0. If you're using a little later version or updated version, that is perfectly fine. Every version would just work fine. Now, as an example, as a test, we are going to create a new virtual machine. So I want you to go ahead and click on a new. And here I want you to type, for example, my Linux VM. So now as you type this, it's going to tell you where it's going to save the information of the Linux machine. So it picked up this location by default. Next one, it says the type. The type is Linux, of course, because I have typed the name, it automatically picked it up that it's assuming there's a Linux machine, and the version is Linux 6, 2.634, or whichever version, and it says 64-bit. Now, if your computer right now or your virtual machine setting is showing 32-bit, which is this, and you do have a 64-bit operating system, then what you need to do is you need to enable virtualization technology in your BIOS setting. So again, if it is showing 32-bit, then first thing you need to confirm is that your computer that where you're running this virtual box actually is 64. So I could confirm by going into my computer. I could go into my computer right here, right click on it, go to properties, and in my computer properties you're going to see that I have a system type as 64-bit operating system. So if this is your system type is showing right now 64-bit operating system, and you're still seeing this version showing up as 32-bit, then it means that you have to go into your computer BIOS setting to enable virtualization. And how to do that, I have included an article in this lecture, in the description, that will make you go through how you could enable that. Anyway, so once you have it enabled, good, reboot your machine and it will show up as 64-bit. Now the next thing is you need to define the memory. Memory is the memory of your virtual machine. It's just like if you are going to a store, right? Let's say if you're going to Best Buy or any computer store, and you pick up the laptop and or computer and you ask how much memory it has. This is exact same way that you are doing, but the difference is that now you are the manufacturer. You are the one who is putting in the memory inside of your computer. By default, I'm going to leave it as 1024 megabyte, which is 1 gig. The next part is hard disk. Create a virtual hard disk now. Leave that as default and click on create. Then it says the file size here is 8 gig by default. It's picking it up. I want you to pick 10 gig just to make sure we have enough space when we are going through all the exercises of our training. Alright, so then hard disk file type is VDI, virtual box disk image, which is by default is the right file type, so leave that as is. Storage on physical hard disk, dynamically allocated, leave that as default as well. If you need to know more about it, what's the difference between each one of them, I'm sure you could go and click on guided mode, or you could also look it up online on the difference of each of these hard disk type. Go ahead and click create. And now you're going to see right here, it's going to show you my Linux VM and its configuration or specification of that VM. The general information showing up here, the system information is up here, the display, storage, audio, network, USB, shared folders, all that. It is just like as if you have an actual machine. So anyway, you have created your virtual machine. This is the lecture I wanted to go through, how you could create a virtual machine. When I am going to go through the next lecture where we will do the actual CentOS or Linux installation, then I will ask you to create the virtual machine again. So for this lab purposes, just go ahead, click on the machine, then right click and click on remove, and then just click on delete all files. Beautiful. All right, so that was just an exercise. Let's move on.
In this video, we will cover the download and installation of Linux operating system. The flavor is CentOS 9 Stream. So what I'm going to cover, we will create a virtual machine, we'll download CentOS 9 Stream ISO, and we will install CentOS 9 Stream. So going back to our lab diagram, we have our laptop or desktop running either Windows or Mac OS. We have installed virtualization software, VMware Player or Oracle VirtualBox. Once again, I am going with Oracle VirtualBox throughout this course. If you want to go with VMware Player, that is perfectly fine. All right, now what we will do is we will go ahead and create a virtual machine on our virtualization software, and then we will download a CentOS 9 Stream ISO image, and then of course, then what we will do, we'll install the Linux operating system on top of that virtual machine. And what is the version of Linux? Yes, that would be CentOS version 9 Stream. All right, so the very first thing is we have to download, so we have to create a virtual machine. So let's go to our Oracle VirtualBox. And here you have all the virtual machines that you created earlier. That's fine. You could ignore that. Click New and put in CentOS 9 Stream. And type Linux, leave it default. I want you to change the version from Red Hat to right here up here where it says Linux 2.6, 3.x, 4.x, 64-bit. Yes. Click on that. Click Next. Now is the memory, which is 1 gig. Leave it default. Next. All right, recommended size of the hard disk 8 gig. We'll change that in the next step. Click Create. Hard disk file type VDI, leave it default. Storage on physical disk dynamically allocated, leave it default. Click Next. Now change the disk size from 8 gig to 20 gig or 30 gig or 50 gig, whatever the disk space that you wanted to specify. Click Create. Okay, now the virtual machine has been created. One more thing you have to do, go to Settings, go to Network, and from attached to NAT, change it to bridge adapter, which will allow us to connect to the internet. Click OK. All right, so now our virtual machine is created. What's the next step? The next step is to download CentOS 9 Stream ISO image, and that we have to download from their website. So let's go to your favorite browser. I'm going to go to Firefox. And let's go to your search engine and type download CentOS 9 and click on the first link and click on CentOS Stream, and by default it'll give you the 9 version. Click on x86 underscore 64 for 64-bit operating systems. It will start to download. This download could take anywhere from 5 to 10 minutes depending on your network speed. I have already downloaded this earlier to save some time. If you are downloading it for the first time, pause the video and let's come back once you have it fully downloaded. All right, so let's assume you have it downloaded and you put it on your desktop. All right, so let's go to our virtual machine that we created earlier. Right here, CentOS 9 Stream. Go ahead and click on Start. All right, it will ask you if you have the DVD, the media inserted into the DVD drive, which we don't. We have an ISO image. So we'll pick this option, which is the folder option. And here you could go to Add, click on Add. These are the few ones that I attached earlier. If you don't see them, don't worry about it. Just click on Add and go to the location where you have CentOS Stream 9 downloaded. So I have downloaded right here on my desktop. Click on it and click Open. And here you could click on Choose. Once it is done, then click on Start. Now this is going to start. It has already attached the CentOS Stream 9 and it has already started. So right here you'll see two options: install CentOS Stream 9 or test this media. So click inside and hit up arrow key and hit enter to start the installation. Now if you want to release your mouse, right now your mouse is trapped inside the window. If you want to release, just simply click on the right control key, which will release your mouse. Now this was the installation of CentOS 9 Stream on Oracle VirtualBox. If you are doing it on VMware Workstation, Simply go to VMware Workstation, and here you could create a new virtual machine real quickly. I will install the operating system later. Linux, it's not 7, and this time we're doing 9. So if you don't see the 9 version on this, that's fine. You could pick the generic one, which is Linux or other Linux 5.x kernel 64-bit. Select this one, click next. The name, let's pick CentOS 9. Next. The disk size, let's pick 20. Store virtual disk as a single file, click next. Customize the hardware if you want to change anything. Yes, we want to. So instead of 768, we wanted to put it 1024, which is 1 gig of memory. Then processor, you don't need 2, you could change it to 1. That's fine. Then network adapter, you need bridge adapter. Good. And everything looks good. Click close and click finish. Once that is done, now I want you to go back again, right click and edit setting. And here you could go to CD DVD and click here use ISO image, browse, and then go to your location of your CentOS stream, attach, open, and it will start the installation process. And it will come to the page just like what I have here. So let's cancel it. Let's cancel it. Just what I have it here. All right, so let's see you have done both Oracle VirtualBox or if you're going with VMware Workstation. Let's minimize this in the back. Let's close these little notifications. All right, welcome to CentOS Stream 9. This is the region, the language, location. It will pick by default where you are. Click continue. All right, keyboard is English US. Installation source, local media. That's fine. Installation destination. Let's click on it and it will pick the 20 gig. Already selected it. That's fine. Good. Just click done. Language support, English, United States. Software installation, server with GUI. Yes, you want the software, the installation to have a GUI as well. Kdump. This is the kernel dump. In case kernel crashes, it will dump or the logs. Do you want it enabled? Yes. Date and time, America, New York. I am in New York, so it is picking it based on my location. It's tracing that. Network and host name. Let's click on that. And the host name, you could pick my Linux VM and click apply. As soon as you click apply, you'll see this will change from localhost to the name that you are typing. All right, it's applied. Good. Ethernet, make sure it is on, it is connected. It will give an IP. Perfect. Click done. All right, now security profile, leave it as is. Root password, this is the password. The root is the most powerful user on your system, just like an administrator on your system. So put in the password that you will remember, please. Confirm. All right. Lock root account? No. Allow root SSH login with password? Yes. Pick this one. And it says the password fails the dictionary. It is based on a dictionary word. You will have to press done twice to confirm. Okay. I want to keep it weak. It's okay if it's based on dictionary. So in order for me to have this installation to take that password, I have to click done twice. One, two. All right, so that is done. Now let's go ahead and click on begin installation. All right, so this is going to create the file system and it is going to create the partitions, the swap space, all that we defined with automatic configuration. Then it will gather all the packages that it needs to install. Then it will go to the package installation, followed by the post installation configuration. Now this could take anywhere from 10 minutes to 30 minutes, depending on the speed of your system. So once the installation is completed, and I will fast forward from this point, I'll see you when it's done. Okay, so installation has been completed. Go ahead and click on Reboot System. All right, so now the system is back online. You could close this notification, and this is asking for a setup. Welcome to CentOS Stream 9 setup will guide you through making an account and enabling some features that will help, which will have you up and running in no time. Let's click on Start Setup. Location services, you could leave it disabled. Click Next. Connect your online accounts. If you have it, connect it. If not, just simply skip it. All right, let's create an account. That is a regular account. So put in your full name. So I'm going to put mine, which is Imran Afzal. And the username, it is picking my first name and last name, but I wanted to change it to my first name initial and last name, full last name. All right, and then let's go ahead and click on next. Password. You could pick the same password as you created for root, or if you're picking a new one, please remember that as well. All right, click next. Password is weak. That's fine. You could change it to strong. I would recommend that if you're doing that in production. All right, setup is complete. Start using CentOS Stream. Beautiful. All right, welcome to CentOS Stream. If you want to learn your way around, check out the tour. If you want to take a tour, please go ahead and take it if you're using it for the first time. But for the lab purpose, we'll just say no thanks. So right here is our desktop. You could go to Activities and click right here, this little icon. This is for the terminal. This is going to go open up our terminal, which we will be using to run the commands, all the Linux commands, and learn everything that we need to know about Linux. All right, so this completes our installation for CentOS 9 Stream. Congratulations.
Hello folks, this is where we're going to do the CentOS installation version 8. Now, as I said earlier, that if you do not want to go through with CentOS 7 and you want to go to with CentOS 8, perfectly fine. This entire training or this entire course covers both 7 and 8, new feature, old feature, everything. And if you again, if you want to, if you prefer, you want to go with 8, let's go ahead and do it now. First thing first, we need to have the CentOS 8 ISO downloaded on our computer so we could attach it to our virtual machine and then we could do the installation. So I will go ahead and open up my Firefox, and I already have my Google open, and I will type CentOS download ISO. The very first link again will take me to the latest version of CentOS. So the first one I'll pick is CentOS ISO Linux DVD ISO, and it will take me to all the mirrors that actually has the CentOS 8 version. And I could pick the first one, a second one, it doesn't really matter. The I would prefer you go with the first one. If it doesn't work, then you go to the second one. Anyway, I picked the first, and now it is asking me to save that file. Now, I have already saved that file previously to save some time, so that is why I'm going to cancel. But if you have not saved it, I would like you to go ahead and click on OK, and it will actually save it to your default location of your downloads. I'll go ahead and cancel at this point. And now, once it's downloaded, I want you to go to your Oracle VirtualBox. And one important thing is if you are downloading and installing CentOS 8, please make sure you have Oracle VirtualBox 6 and above. This is the one that is mostly compatible with CentOS 8. If you do not have 6.0, you could go into the file and click on check for updates, and it will take you to the right link where you could actually upgrade your Oracle VirtualBox. Anyway, now we are doing CentOS 8. I want you to go ahead and click on a new, and type in CentOS or Linux CentOS 8 or any name you decide. The name is not important. Anything that you could remember or you could relate to. And by default, it will pick type Linux, the version Red Hat 64. You could pick 64 Red Hat, or you could actually pick the one that you picked, or if it shows up as other 64, doesn't really matter. So I will leave it as default that it picked Red Hat uh, 64 and click on next. The memory 1 gig, leave that default. The storage, create a local virtual disk. Click on create. Leave it default VDI, default dynamic allocated, and now the size of the disk, I would recommend that you pick 20 gig. Go ahead and click create, and now it has created your Linux CentOS 8. Go ahead and click on power on. Once the window opens up, it will ask you to check where is your ISO image file is located. My ISO image file is on the location. When you click on this little folder, click on that, and if you have your ISO image file downloaded on your desktop, then you go to your desktop or wherever the location is. My location is my personal folder in ISO folder, and here is the ISO image for me, CentOS 8. Click on open, and now go ahead and click on start. Okay, so this is the page where it gives you two options. The first option, it gives you install CentOS Linux 8.0. Second option is test this media and install CentOS Linux 8. Now, if you have the physical disk attached to your virtual machine or your physical machine, then it's always a good idea to test that media because many times that physical media has scratches on it. So it will create problems during the installation. But since we have downloaded the ISO, then it's best and it's perfectly fine if you pick the first option. So you go ahead and hit the up arrow key, and it will highlight install CentOS Linux, the very first option. Go ahead, click enter. If you see this message top, you have the auto capture keyboard option turned on. This will cause the virtual machine to automatically capture the keyboard. That is perfectly fine. You could close it. Basically, what it's saying is if your mouse is stuck inside of this window, it's because we have certain features enabled. You could get out of this window by clicking the control key, the right control key on your keyboard. So I will just simply go ahead and ignore these messages by clicking the close. Now basically what this is doing right now is it is actually copying some of the information from the ISO image that we have attached. It is taking that and copying it into its memory. And the memory will actually see, hey, give me the installer that will allow me to go through the installation wizard to do my CentOS 8 installation successfully. So I'm just gonna have to wait for it to start that GUI, that installer, and once we have that, then we go through the installation. By the way, you could also do the command line installation. So on the very first page, you could have done that modification as well. But if you're doing it for the first time, I will definitely recommend you go through the GUI installation. So as you see, it's showing starting installer. So give it a minute or less than a minute. I'm very hopeful. All right, on this screen you will get the welcome to CentOS Linux 8.0 or the build. It could be 1905 or whatever. What matters is version 8. What language would you like to use? We'll pick English, and I'm in the United States, so I'm going to pick English in the United States and click on continue. On the second screen, you're going to see installation summary. CentOS Linux 8, the keyboard is US. You could leave that as is. You don't need to click or change that. The localization, the keyboard, it is automatically testing and it notices that we are in the United States. So it's going to pick the keyboard as English US. Next one is language support. It's United States and English. The time again, it's America, New York. If you are in a different region, then it should pick up that region. If not, you could click on it and you could select the desired region. Next one is on the software selection. You're going to see installation source, which is our ISO image. So that shows up as local media. Second one is software selection, server with GUI. By default, it's going to give you server with GUI. You could go ahead and select this option. And you're going to see in the base environment on the left hand side, these are the base environment. On the right hand side are the add-ons for selected environment. Um, every base environment has all these add-ons. So if you go to, for example, server, you're going to see these different servers that you could run or these different applications that you could run on your server. You probably heard of FTP, NFS, DNS, all these services that actually runs on Linux or on a server. You could pick based on your requirement, or if you are doing in the production, you could pick depending on your application team requirement. Again, minimal install meaning when you pick this one, it will not install GUI. But with that minimal install, you could also pick some of the tools that you think are appropriate to do your troubleshooting or systems tool configuration. Workstation, this is a workstation, is a user-friendly desktop system for laptops or PC. Custom operating system, virtualization host. I actually want you to go through each one of them, go through each and every add-on package, and just make sure you understand and make yourself aware what are the packages or add-ons we have available. But for this training, I want you to simply select server with GUI, which was previously selected as a default, and go ahead and click done. Okay, once that is done, you're gonna notice that it's checking with this ISO image. Hey, I need server with GUI. Do you have all the required packages and the local media, which is the ISO image? It says, okay, let me check. And it goes back and look through the packages and says, yes, I do. That's why you see both of them now into the black font. The next one we have right here is installation destination, meaning where do you want to install your operating system? Which disk do you want to install it on? And you remember when we were configuring the virtual machine, we carved out 20 gig. And by default, it has that 20 gig selected, as you can see right here. In the storage configuration, I'm going to leave it as automatic, which means I am going to let Linux decide how it wants to partition this 20 gig. If I click on custom, then I would have to specify, meaning I want you to give 5 gig to home, I want you to give like 5 gig to var, I want you to give the remaining to root. That comes into custom. So this is a very beginning. I don't want you to get into this because it requires some extra skills. If you are doing it, the installation for the first time, then my suggestion is leave it as automatic and go ahead and click on done. Okay, next option under the system is kdump. Kdump stands for kernel dump. If something goes wrong with your system, something crashes, and if you have that kdump enabled, then it will log all the errors and all those messages. So you could go back and review what caused the server to crash. So I'm going to leave that as enabled, or which is selected by default. Next one is network and host name. You click on it and let's change the host name. Right now it shows up at local host.local domain, which shows on the right hand side, says current host name is localhost. Let's go ahead and change it to Linux CentOS 8 and click on apply. Again, you could pick any host name that you like, and then you could apply it, and it will show up on the right hand side. This one shows our networking right now is disconnected because it's turned off. Here's the hardware address, which is the MAC address. Here's the speed, which is a 1 gig. Go ahead and click on configure. And on this screen, I want you to go to the Journal tab and click check mark automatically connect to this network when it is available. It means every time your computer or your operating system reboots, it actually going to connect to the network automatically, so you don't have to enable it or start the network again. Go ahead and click save. And now you're going to see it has some more information like IP address, default route, DNS. So go ahead and now I want you to click on done. So host name and network is done. Security policy, if your company has some security policy or if you're installing CentOS 7 or 8 in your production environment, consult with your security folks, find out if there are any security policies that you need to apply. But I would say 9 out of 10 times this option is not usually selected, so leave that out and click on begin installation. Alright, while it's starting the configuration or doing the pre-check of the installation, it's going to ask you for user setting. It's going to ask you for root password. You need to set the root password and you need to define at least a user. Let's go ahead and click on root password first. I'm going to specify a root password. Based on my choice, it is weak. I understand. I do not recommend you guys to pick a weak password, pick a strong password. But since for me this is a lab, so I'm gonna just leave as is. And by default, Linux sees it as a weak password, and it asks you to press done twice to confirm. So if your password is weak, then you have to press this done button twice, 1 and 2. And now user creation, let's pick a user. I'm going to pick myself, Imran Afzal. Of course, you have to pick your own name. And by default, Linux picks the first name, initial, and the complete last name. Leave these settings default and pick the password. Our password, again, in my password is weak, and that's fine. I'm going to press the done button twice. Alright, so now the prerequisites for the installation is done. Now it is downloading packages, meaning it is going to that ISO image, and it is asking, hey ISO image, give me all my required packages. And now it is preparing transactions from that installation source. And what is that installation source again? It's our ISO image. Now once that is completed, then you're going to see the actual number of packages that will show up that actually are needed for this installation to complete. And once you pull it, it will show you. So most likely it's probably going to be somewhere around 1200 or 1300 packages because we are going through the GUI installation. When you have GUI selected, GUI takes a lot of add-on packages as opposed to the command line or without the GUI installation. So anyway, so if it comes up like 1300 packages, you need to leave it running. It could take anywhere, I would say the installation would take anywhere from 10 minutes to 30 to 4 or 45 minutes, depending on your computer resources, depending on the speed of your computer. So I would say at this time, you could go ahead and take a coffee break or a lunch break, and then you could come back after half an hour. And what I will do is I will go ahead and fast forward from this point on. So this way I'm not going to waste your time and my time, and then once it's done, I will meet you on the other side. All right, congratulations, guys. We have successfully completed the CentOS installation. As it says right here, complete. CentOS Linux is now successfully installed and ready for you to use. Go ahead and reboot to start using it. So, of course, go ahead and follow the instruction and click on reboot. All right, when you get to this screen, you're going to notice that it is starting back again on the CentOS Linux installation screen. The reason it is doing that is because by default your ISO image is still attached to this VM virtual box. So what you need to do is you need to remove that ISO. So when your system reboots, it doesn't think that it has to boot off of that ISO image. So for that, I would tell you to go to So to get out of this window and release your mouse, click the control key on the right hand side of your keyboard. Okay, so and click on devices, optical drives, and simply click on remove disk from virtual drive. Then it will prompt you to force unmount, meaning remove it forcefully. That's fine. Go ahead and click force you unmount. Now it is unmounted. You could verify again by clicking on devices, optical drives, and there isn't anything that attached. Beautiful. Now you need to reset this machine. Click on machine and click on reset. It will prompt you, do you really want to reset the following virtual machines? Yes, that's fine. Click reset. Now it is starting your CentOS version 8 operating system. Okay, when you get to the initial setup page, you need to select the license information. By the way, if you got to this page after 2 minutes or 3 minutes, that is perfectly fine because this is initial configuration. First time your operating system is started, it could take some time. It could take longer than what it will take you later on. Go ahead and click on license information and click on I accept the license agreement. Of course, I would recommend that you read through it and click on done. And then click on finish configuration. Alright, when you get this to this screen, meaning that it's waiting for you to log in now. So I have created my account earlier during the installation. So I will click on it and it will ask me to put in my password. So if you go back again, click cancel, and you want to log in as root, then you have to click on not listed and provide the username as root. And then you need to provide the password for the root, and that is the password that we picked during the installation. Anyway, I want to cancel it. I want to log in as myself. Once again, if you're logging in for the first time, then it will take some time for the operating system to come online. So don't worry, be patient. If your mouse is captured inside of this window and it's not going outside of it, then please remember you could click the control key, the right control key on your keyboard to get out of it. All right. So the desktop, the only important thing that I see on the desktop is your terminal. So right here, you could go ahead and click on that terminal, and it will give you the platform to actually run all those commands that we're gonna learn throughout this training. So that terminal is you could use either console and use that terminal, or what we could do is we could find out the IP address of this Linux machine, and then we could log in as through PuTTY. Anyway, logging in through the PuTTY is something that I will show you later. But anyway, at this time, again, as I said, since this is started for the first time, it's gonna make you go through some initial stuff. Like at this point, it's giving you a welcome screen. If you need to change your language right now, you can, but just leave it default. Click next. Typing again is selected for me. Click next. Location services, I would like to keep it turned off, so I'm gonna move this to the left and click next. Connect your online accounts. I would not like to use those right now, so I'm gonna go ahead and click on skip. And the last option, the last screen is giving me you are ready to go, start using CentOS Linux. So click on start using CentOS Linux, and it should go back to your desktop right after that, where we have our terminal that we opened up earlier. Alright, so again, as I was saying, this is the terminal. That's the one that you need to use to run all the commands. And you could get yourself familiarized with the desktop as well, the GUI desktop. But I would say 80% of the environment and the production corporate environment do not use GUI. So be ready to use command line. Don't get too comfortable with the GUI. Anyway, congratulations once again. You have completed the CentOS 8 installation successfully. Now you could go ahead and close this help window. That will also give you some information about Genome, that will tell you about the GUI. Anyway, good luck, and let's get moving on to the next lectures, where we'll learn a lot about the command lines and the commands that you need to learn.
Getting internet access to your virtual machine. Now, in this module, we will cover different components of networking. We will learn a little bit about how networking works in a Linux environment. So before we get into the network, we do need to allow access to our Linux machine. And in order to allow access, we have to make certain changes to our VirtualBox manager. Basically, we have to go to the network setting and change its network adapter to Bridget adapter. So this way it will get its network through your laptop or through your desktop. So let's go right into the change. Alright, this is our VM that is running. I want you to go to the setting, network, and change this attached to bridged adapter. Once you change it, leave everything default. Click OK. Once it's set, let's go to our virtual machine, and then here we will try to do ping.google.com, and right now it's telling me that the service is not available. So let's become root, and then just simply reboot the machine. To reboot is init 0, or just type simply reboot. Let's open up the terminal, and this time I want you to run command ifconfig and pipe it to more, and you will see here the IP address has changed. It is given the IP addresses of the same network that you have set up at your home. So now when you try to ping www.google.com, you should get the response. See, it's getting the 64 bits. response back from the server. Ping is the command that is used to communicate to other servers. So now we know that our machine is ready. It's on the network. We could download the packages. We could install the packages. Anything that we want. It has ability to go on online. Now let's get into the network side of Linux. Of course, this is not network where you're going to be learning switches and routers. That's completely a dedicated network job that you should look into. But in Linux, even if you are system administrator or engineer, you have to know a few things of network. What it means is when you are building or installing a Linux machine, you need to configure an IP address. You need to know certain things, certain components of network to get it working and get it online. What are those things? Of course, the first thing is IP. IP stands for Internet Protocol. IP address could be like, for example, 192.168.1.234 or whatever. So depending on the organization you are in, you're going to have a different range of IP addresses. So your job is to assign an IP address, and you should know what an IP address is and what it looks like. Subnet mask is an associated way to attach it to the IP address. And then we have a gateway. Gateway tells your computer which route you have to pick to send your traffic out and to receive your traffic in. So if you are in your home environment, your modem, the IP address of your modem will be your gateway. Then we have the static and versus and DHCP. What static is, if you are given an IP address from your company, from your corporate environment, and you have to assign a dedicated IP to your machine, that is called static. And when you reboot your machine, that IP does not change. Whereas if it is set up as DHCP, the IP address will change. It will pick an IP from a pool of IP addresses, and every time your system is rebooted, most likely it will change its IP address. So in most of the corporate environment, you will be setting up a static IP address. Then you have an interface. What interface is, if you look at your laptop or your computer, in the back of it, there's a port where you connect your Cat5 cable. That's an interface, a NIC card. So interface always have a MAC address that is a permanent MAC address to your NIC associated with your card, and this MAC address never changes. Network files and commands. There are many network files and commands that needs to be used in order to configure your machine and bring it online or bring it to the network so it could communicate from one machine to another. It should have an interface detection. Assigning an IP address to the system is very important when you bring up a system and you need to have it on the network. The interface configuration files are, the first one is etcnsswitch.conf file. This file is located in every Linux distribution. In fact, all these files that I'm going to talk about, all of them are and will be in your Linux system. So the first one is nsswitch.conf, which tells the system where it should resolve its host name to IP address. So let's look at our Linux machine, and then we will find out how to read these files. Let's clear the screen. Okay, the first file that we're gonna look at, it's etc and a switch. So just do cat on etc and a switch.conf file. You will see it's starting with host. So let's do more on it instead of just cat. So this will read the file page by page. Okay, so all these stuff, anything that starts with pound, it means it's just a comment. Anything that you want to have it in effect, just remove the comment. So let's go through it. Let's go to the point where we don't see the comments. So here it's starting from this page on. It says a password file. So the first thing is telling you to look for the password file in the files. Don't go anywhere. There's no Active Directory. There's no other NIS service that's running that's going to give you the password. So look for etc passwords. Shadow is also etc shadow. That's local. Group is also etc group. And when you come down to host right here, it's going to tell you the host information of your system is located in the files, and that is etc host. And then it's going to say if you can't find it, then go to DNS. DNS is another service that is installed on a Linux machine, or it could be installed in a Windows machine. We'll cover that later on, but for now, this is the NS switch file looks like. And if you want your host to be resolved with DNS first, you switch DNS here to here, and file comes the second. So this is the NS switch file. You're going to be seeing this configuration of this file many times while you're doing system administration. Next one we're going to look at is etc host. etc host file is where you define your system IP address and system host name. So if my system IP address is ifconfig, it's 192.168.1.14, I could go into that etc file by becoming root, vi the file, and I could go at the bottom and I could put 192.168.1.14, and the host name of my machine is oh god, let me save it, and there you go, my first Linux OS. So let's do it again. It doesn't matter uppercase or lowercase, but my first Linux OS. My first Linux OS. So now if you ping my first Linux OS, it's gonna ping your IP address. You see right here, the one that you specified in the etc file. So that's what etc file does. It's a very tiny version of DNS that's sitting in your machine. The next one we have etc sysconfig network file. This file, sorry, it's network, I believe. No, network probably. Yep, I'm right. So this is the file where you specify your host name as well. Right now it's empty because we have hard coded the host name, but if you want to change it, you could modify it here, and certain other parameters can be set too. Of course, you are more than welcome to look it up more on the network file. The next file that we're going to be covering is actually the file that's where you specify your IP address on all the network, all the subnet mask and gateway. And when you are in the directory etc sysconfig network scripts, I want you to do ls-ltr, and the last file you're going to see is ifg enp0s3. And what is this, the last one? It's actually your interface. If you go ifconfig, and you'll see right here, this is the name of your interface. So remember, every time all those interfaces files always start with if cfg dash and the interface name. So when you vi that file, here you'll see the boot proto is defined as DHCP. You could change that here as static, and then you could define the IP address, you could define subnet mask, gateway, and this way your IP address becomes permanent in your machine and does not change. So these are a few of the files that I really want you to understand and memorize it, because if you are going to go into Linux jobs and you're going to be applying for it, oftentimes you're going to get questions on these, where these files are, what the files do, where they're located, and so on. So let's exit out of this file. The last file I have is etcresolve.conf. etcresolve.conf specifies your DNS server. DNS server is, once again, it actually resolve hostname to IP, IP to hostname, and hostname to hostname. So if you define it here, every time you go to www.google.com and hit enter, it knows Google is, I have to go into, this is my gateway. I have to go to my gateway, which is right now acting as a DNS server. I'm going to go to my DNS server and ask, where is Google, and how to translate Google to IP address. And it has translated, and this is the IP address of Google. Let's go back to our lesson. The next one, we have the network commands. The network commands, we have learned ping already. If you wanted to ping a server, let's say ping www.hotmail.com, that's a server outside. That command that you will run is ping. If config tells you what your interfaces are in the system, we have right now 3 interfaces. The local one does not count as an interface, and the other one you could ignore it. The only one that I have is just one, and this is right there, and it's telling me my IP is configured this. Then you have if up or if down. If you want to bring down this interface, if you don't want a network, you could type if up, if down, or if you want to bring it back up, you type if up. Then the next one, we have netstat. Netstat you could run with different options. I run is usually with R and B. This one tells you your gateway, how your traffic is flowing, from which interfaces is flowing from. And the last one we're going to cover is TCP dump. TCP dump, it actually traces every single transactions that are leaving your machine and coming into your machine. To the command to run is simply TCP dump. You have to specify I with the interface, which interface you are sniffing. It's basically a sniffing tool, and then you run it, and you'll see every listening coming in, going out. It's actually listed here. So that's how you actually run this TCP command. That's how you run all these commands, and please memorize it. Please run a man command on each and every one of them, and familiarize yourself how these network commands and files work. NIC information. What is a NIC? NIC stands for Network Interface Card. That is something that is attaches to your computer, your desktop, or your laptop. If you look at the back of your laptop, you will see that little port where you connect the Ethernet 5 or 6 Cat 5 or 6 cable to it. That's the card installed in your computer. And the port that is associated or attached to the card, that port is called NIC. In Linux or in computer world, it's called NIC. An example to find the information about the NIC is that you run a command eth tool followed by the name of your NIC. And how do you find out the name of your NIC? Think about it. How do you find out the information about your NIC? You run the command ifconfig. That will give you all the interfaces of your computer. Now, if you run ifconfig, you will see other NICs as well. What are those? Well, there is one of the NIC that you will see that shows up is LO. LO stands for loopback device. Is a special interface that your computer uses to communicate within itself. It works as a diagnostic and troubleshooting, and to connect servers running on the local machine. So it's like, you could say, a private communication within itself. Then you have another NIC that you probably will see in your machine. If it's a virtual machine, it's VIRBO. This stands for Virtual Bridge 0. Interface is used for NAT. NAT stands for Network Address Translation. The virtual environment sometimes use it to connect to outside network. So I don't want you to really focus on VRB0 or even LO, because you will be seeing this, but there is not main function of this. The only function of the interface that is used to communicate to other computers is the third interface, which is usually labeled as, if it's an Oracle Virtual, it's ENP, or if it's a regular server, you're probably going to see ETH012 or so on. So we will run this command eth_tool in our environment and see how we could get the information about our interface. So we'll go into our Linux machine, and this time I want to log into my system using our console. So the console, or you could use putty session too if you want to. So let's see if I have a putty session. I'll just execute the putty session right here. But in order for me to run putty session, I need the IP address. How do I find the IP address? How do we find it? Ifconfig. Now you should be comfortable enough to run this command all the time. Ifconfig, I'll put more, because if it doesn't fit on the screen, it will give me one page at a time. And the IP address that I have for my interface is this: 192.168.1.12. I will log in as myself, and in order for me to run the eth_tool command, I have to be root. So I am root. Let's clear the screen. Let's get rid of this one, minimize it since we already have the putty. Let's make it a little bigger. And now we'll talk about the interfaces. Again, how do we check our interfaces? Ifconfig. As you can see, we have the main interface right here, which is the one that is used to communicate to other computers or outside world, and it has an IP assigned. The next one is LO, which I have already explained, and the third one is VIRBR0, already explained in my slide. I want to get information of VRBRO, so let's say eth_tool and VIRBR0, and it will say link detected, no, so forget that. Then next one we want to do is eth_tool LO. Link detected, yes, but there's not much information that's out there because it's the system's its own interface, so we don't have to worry about that. The one that we have to be concerned with is eth_tool ENP0S3. Where do I get that? Right from here. See this interface? This is the name of my interface. So I will run eth_tool followed by the name of my interface, and I'll hit enter. Once I hit enter, I have right here my command output starts from right here. This is what is telling me that setting for interface is supported ports is TP, supported link modes, it supports 10, which is 10 meg, 100 meg, and 1000 meg. What is 1000 meg? It's 1 gig. So my interface supports 1 gig of traffic. Nowadays, if you're running your computer on a very high speed network computer, you will see 10 gig right here. So a few things that you do have to get out of this command eth_tool is one, this whether its link mode is 1000 or 10,000. Second, you have to know, of course, the speed is 1000 megabytes, which is the same as this one. Then you need to know its duplex. Is it full, half duplex? These are the things you have to provide to your network administrator, because when your computer is connected to a switch, and switch has to be configured for your port to allow the traffic to come in and leave your server, your system, your network administrator will ask you for that information. So be ready for that, and remember the command to find that information is eth_tool. And the last one is link detected, that your interface link is up, is active, it's not down. If you are troubleshooting it, you can find it. If you see no here, then it means there's something wrong with your network card. Alright, try these commands. Run man command on ETH tool and try with different options that is given and see what are the options gives you the exact information that you're looking for. Hello everyone. Since we are on a network configuration part of the Linux, we'll talk about NIC bonding. What exactly the NIC bonding is. Just to let you know, NIC bonding is one of the very important and critical aspect in Linux network configuration, and this type of questions are asked oftentimes in an interview. So let's see a NIC. A NIC stands for Network Interface Card that is attaches to your computer. So if you look at your laptop or behind your PC, you will see a little port in there, and that port is your NIC. With NIC, which is Network Interface Card, bonding is also known as network bonding. It can be defined as the aggregation or combination of multiple NIC into a single bond interface. Its main purpose is to provide high availability and redundancy. So let's look at our picture. We have this 4 NIC cards on our computer. So what we do in NIC bonding is we take 2 ports, we combine them together, and the reason we combine them because what if one port dies? We still have another port. So this is for the redundancy. So another way to make 2 ports redundant or to have them high availability is you combine them together. If a port is 1 gig and the other port is 1 gig, you combine them together to aggregate them and get the throughput of 2 gig. This is achieved for high availability and link aggregation. So NIC bonding procedure is that you type mod prob bonding, which is to get the configuration of your driver, info bonding to get the information of your bonding. Then you create a file called ifconfig bond 0. You added the first Ethernet 1, you added the second Ethernet, and you combine them and point to bond 0. If you have NIC 1 file, you create another NIC 2 file for the second NIC, and then you create a third file called bond 0. You point your NIC 1 and NIC 2 files toward bond 0. And then what do you do at the end? You restart the network of your computer. So the command is systemctl restart network. So without further ado, I will log into my system and I'll tell you exactly how NIC bonding can be done. And before we start this VirtualBox, I want you to take its snapshot. The reason I'm taking a snapshot is so we could revert back to its state, which is where it is right now after we do all the configuration. So click on right here, you see snapshot, click on snapshot, and right here says take, click on the take, leave the snapshot number 1 as the name default and click OK. Now it has taken the snapshot. Now I want you to click on setting, go to network, click on network adapter 2, check enable network adapter and select bridged adapter. Now we will have 2 NICs on our computer, which is one here, adapter 1 and adapter 2. If you want more adapters, we could go to adapter 3 and 4 and check on enable network adapter, but we will work only adapter 1 and adapter 2 at this time. And I want you to click OK. So once the setting is done, go ahead and click on start. Go ahead and log in as yourself. Okay, when you have the desktop, right click on your desktop and open up your terminal. I would like to make the console, the terminal, a little bigger. Okay, go ahead and type ifconfig and do more on the output, and here you will see now we have 2 network interfaces. One is ENP0S3 and the second one is ENP0S8. ENP0S8 is the one that we just added to our Oracle VirtualBox. Now what we want to do is we want to combine these 2, 3, and 8 together and make a bond out of these 2 interfaces. Become root first. Okay, let's clear the screen. Now I will open up a document that I have that has all the commands and configuration in my document. This document is also added as part of your handouts. So before you do this exercise, I want you to also open up this document from your handouts, have it side by side while you do the configuration of bonding. So I have already opened this document. Okay, so now it says just follow the directions. It says add a new NIC if it does not exist, install bonding driver, mod prob in bonding. You would need to install this if you don't have bonding enabled, but let's say if you do have it or not. So do mod info bonding, and I want you to do more on it. And once you do more, and if you get the output and description says Ethernet channel bonding driver version 3.7.1, that means you already have the driver installed, which is the mod probe in Linux, so you don't have to worry about installing it. So you can move on to the next step. Okay, the next step is to create a new file called icfg-bond0 right here, and I have to create this file in this directory, in this path. So if I copy and paste, it's not going to work, so I have to type it. So I go back into our machine and I'll do vi etc sysconfig network scripts cfg-bond0. Now you are in VI mode. Hit I to insert, and I want you to start typing exactly what's just written in there. Please make sure, don't make a mistake. Type is bond. Name of this bond is bond0. Bonding master, meaning who's the master of this bonding, it's itself, so yes. So boot proto. So when you type none or static, it means the same thing. So we'll type none. On boot, yes. IP address. I'm sorry, there's a little mistake. It should be just IP ADDR. The IP that I have picked is 192.168.1.80 because I have already typed this IP before and I know this IP does not exist. Nobody has taken it. But if you wanted to confirm if this IP is not taken, you could just go into, you could open up another terminal and do ping 192.168.1.80, and you will see you are not getting a response back on that IP. So it means it's not taken. So I'll use IP. I'm assigning the static IP. Netmask 255.255.255.0. Gateway. Gateway is the IP address of your modem. And then bonding underscore options equal mode 5. I'm picking mode 5, and what exactly mod 5 is, or mon is, this is the speed and the state. I have also included that in my document exactly what these options mean, and I want you to review them and you will know exactly what it means. So now you could just save and exit the file. Okay, once you have that,
It says the bonding options detail can be found here. You see right here, it has all the options. We picked, if you remember, we picked option 5, which is transmit load balancing. You could read about it. And then MIIMON, which is the monitoring, MII link monitoring frequency in milliseconds. We picked 100. Okay, so next step is, it says edit the first NIC file, which is ENP0S3. So I am in root directory. I'll go into etc sysconfig. I'll just drag this a little more so you could see it a little better. Sysconfig cd network scripts, and in this directory I already have a file called etccfg enp0s3. Do vi, and now I have here, I said delete the entire content. So how do you delete it? In the vi you do dd 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 dd, keep doing dd 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 until you go to the bottom. You are at the bottom and it says no lines in buffer. That's good. Now hit enter. Sorry, not enter, hit insert. You probably have to hit insert a couple of times to get it. So now keep typing what exactly it's in there. So type Ethernet boot proto none device ENP0S3 on boot. Yes, you want to have that boot. Hardware address, this is a new one. Now this is the MAC address of your ENP0S3. So what is my hardware MAC address? You have to open up another terminal in the back, drag it, and then just type ifconfig and do more, and you will see ENP0S3 has a MAC address of this. So what I will do is I'll drag this a little bit on top. I'll bring the other window in the back, and now I could type the address 080027 C3 0E 28 verified 27C3028. yes, and then hit enter. Master, it's asking you who's your master. The master is bond 0, which is the other file that we created before that. Hit enter. Slave, are you a slave? Meaning this interface, is it a slave? We'll say yes. So check again, boot proto, boot, oh, we missed one. Oh no, we did not, it's there. Type boot proto device on boot hardware address, which is a MAC address. Master is bond 0 and slave is this. Okay, now save and exit. Okay, now follow the directions. Okay, now it says create the second NIC file for ENP0S8. I could create a second one, or I could just copy this ENP0S3 and change the name and MAC address. So it would be easier. I could just copy ENP0S3 and I name it CFG dash ENP0S3 and take out, replace 3 with 8. Now it's copied. Now VI CFG ENP0S8. Now in 0S8, now you have to change this third line. It says device 0S3 with 8. Yes, yes, and now the MAC address would be different. Go back to your other command that is open, drag it up, and you will see here the MAC address for ENP0S8 is this one. So once you have it highlighted, drag it down so you could see it, and now change it. It is changed after the 3 octets. So 0D 17 9B. Okay, bond 0 master is the bond 0 slave. Yes, I am a slave for bond 0. Then right quit and save the file. The file is saved. Now I want to restart the service. System CTL restart the network service. So network restart. Hit enter by running ifconfig. Do the more on it, and you'll see now the IP that I have assigned, or says right here 192.168.1.80. It's master, and the other ports, sorry, other NICs, ENP0S3 and S8. You'll see here, right here, it says these are slave and slave. So IP assigned is given 192.168.1.80. I'm gonna take this IP, plug it into my PuTTY session, and see if I could connect to it. 192.168.1.80. Hit enter. Yes, I could connect. This is just a SSH key warning sign. You could just accept it to save it and log in. And yes, there you go. So now you know that your interface is combined together to and pointing it to bond 0. Any other instructions that we have, we could go down. We could also see here, it's telling me that I could verify the setting by doing cat etc net bonding and bond 0. When I do that, I should not have, okay, let me make this bigger. And now you'll see here when I did the cat, you see it says currently active slave is this one. It is load balancing. Slave interface is this, and second slave interface is this. Now once it is done, I want you to revert back to your original VM. So just close it, power it off, close, and it says power off the machine. You power it off. Now go to your Oracle virtual machine right here, and first wait for it to power off, then go to setting, and then come to network, go to network adapter 2, uncheck the one we checked before, click OK. Now it should not have the second adapter, but I want you to click now to the snapshot 1 and click on restore. Now this is going to restore to the original state where we had it before. Here it will create another snapshot of your current state, which I don't want you to do, so uncheck this box and click restore. Now it is restored to exactly same way where it was before we started this lesson. Alright guys, I hope you enjoyed it, and please try it on. This is one of the topic that's very important. You will be working on a physical machines most of the time when you have to do network bonding. Downloading files or applications. Well, in Windows, when you have Windows machine, Windows PC or laptop, if you need to download anything like an application or a game or a file, what do? You actually open up your browser, type in the link in the URL if you know the exact link, and you click it. It will take you to that page, and then you click on that download link again, the next one, and it downloads it right here. But in Linux, we don't have the GUI. So how do we download a file, or how do we download an application that we need to download? Well, there is a tool in Linux that's called wget. W stands for World Wide Web, and get is, of course, to get it. So get it from World Wide Web or to the internet. This is the command that you'll get. And an example of the command is wget followed by the exact URL where the file is located. If the file ends with .tar or .zip or .msi, whatever that is, you specify the entire URL in the wget command. Now, the question is, why? Why do we even need to download any file or any application or any program in Linux? That's a very good question, right? But there's one thing that you're missing, and that is the yum command. You're probably thinking of the yum command. When you have a Linux machine and you need to download any package or any file, you could just simply go to yum followed by the name
of the package or the file and then install, and it downloads it for you. As in this example, you have a server, and the server goes to another server to get a file. In this case, is this that server is the mirror or the repository where the yum goes and install all the packages. But that server does not have that file that we are looking for. Then it goes to another server. Our computer will go to another server, but that server is not listed as one of our repository. So what do we do? How do we get that file from that server to our server? We get it through the wget command, and that's how we install it into our machine. So let's take an example of our Linux machine. I will run the wget command in our Linux machine and see how it works. I will run it through the PuTTY, but before I run it through the PuTTY, what do we need? We need the IP address of our PuTTY session, of our Linux machine. And how to find the IP? This is something that you should know by heart. So I have 192.168.1.12. I'll put that in here. 192.168.1.12. I will log in as myself. And the reason I have this IP instead of 192.168.56.101 is because I have in my virtual machine, if you go to the setting and you go to network, I have bridged adapter. If I had host only adapter, then there would be a communication between laptop and this virtual machine. But now I wanted to actually go outside of the network, so that's why I have this bridge adapter. And how am I connecting on my laptop or my desktop? It's through the wireless, right? So just make sure you have these settings. So I do, and I know I have this IP address. I use the PuTTY, I put in the IP address, I'm in. So now I'm just simply go in and minimize this. And I will minimize this as well. And I will take an example of, let's say I wanted to install PuTTY in my Linux machine. So in order to install it, you have to run yum command, and before you run yum command, you have to be root. So I'll do yum PuTTY install. That's a command, right? To install any kind of PuTTY or any kind of packages or file you're looking for. Okay, so the yum went outside to its repository and asked, do you have the package PuTTY? It says, no, I can't. Sudo command PuTTY, please make sure yum, sorry, I did run the command wrong. It is yum install PuTTY. I'm sorry, but that's okay. Mistakes happen, right? Okay, so yum install PuTTY. You hit and enter, and then you'll see at the end it says no package PuTTY available. Error, nothing to do. So it did go out to the yum repositories. It did not find the PuTTY package. Now this is a perfect example. Now at this point, I do need a PuTTY package for my Linux machine. So what do? Well, you need to find out where the link URL of the PuTTY session is. So I'll go into a browser and I will type in google.com and I'll go to download PuTTY. I'm just going to the Windows machine and to the web browser so I could get the link to download the PuTTY. So this is the package for Unix source archive. This is the one I have to download. So I'll right click to it. I'll go to copy link location. So it has copied the link location. I'll come here and just type that location here just to make sure that it does show me that it will download the file. Yes, it will. See? So you just cancel it. Now you go back to your Linux machine, and now at this time you type wget. It's a long link, so just make sure you extend or maximize your window, space, you right click on your keyboard and it will paste the entire URL for you. So this is the URL, and once you hit enter, See, it is connecting, it is downloading. You see that? Amazing. Amazing. We have that package now. Where is it? It will be downloaded in the current working directory where I am. And where am I at this time? Let's do pwd. I'm in root, so it should be in the root. And this is it. putty-0 the version .tar.gx. So that's the reason we need that wget command. So people or users or developers who cannot find their packages that are on a third-party vendor's website, they could use wget command to actually download a file or package or whatever that they're trying to install.
Curl and ping commands. Why do we need them? Well, those two commands are so useful when you are troubleshooting system network related issues. So if you are a system administrator and you get a call from someone and says, "Hey, Mike, this server is not reachable, or this machine is out or down, or I cannot ping this address, or I cannot reach this website." So what are the first few things that you need to do? Well, first thing and are that you try to communicate to that server yourself to see if you could reach it, right? So how are you going to communicate to it? So there are two very basic commands. One of them is curl, and the second one is ping. So you have this Google website that you go on Windows, you log in, you go to www.google.com, perfect. You could reach it, so you know how it is. But what if you in Linux system you don't have the GUI or you cannot open up a browser? You have to find out how that works, right? Just like the wget command. So for that we have in Linux we have curl. Now, curl is specifically is for the URL. So as you could see, it's C and then URL. So you grab that URL and see whether you could get to that specific HTTP site. So you could ping the site. Let's say if you're pinging google.com, it will come back with the IP address. It will try to ping that IP address, and you will see, hey, the server is up. Okay, but if the server is up, what if the page is not up for that server? And the page is actually run by what? It's run by Apache, right? HTTPD. What if the server is up and page is down? Then you need this curl command, which is very handy command to find out if that page is up. And of course, the other one is the ping. Ping, you ping the server if you are server A and you want to see if the server B is up or not. You ping that server by its host name or by its IP address. So the example in Linux for curl is that you specify the HTTP and the entire URL, and it will bring you back the content of the page. Not exactly the way it looks when you open up a browser, but it will bring up all the HTML source code most likely or some other information. But when it brings it back, it means the page is up. Then you also have curl minus O, uppercase O option if you wanted to download a file. Remember, we could use wget command as well. Well, in some computers, if you don't have wget, you could use curl command to download a file to your Linux machine. And of course, at the end, we have ping if you want to ping a server by host name, which is, let's say, google.com or your system host name with the fully qualified domain name, you could use ping command. So we will try curl and ping one by one in our Linux machine. So this is my Linux machine, and this time I wanted to log into the Linux machine through PuTTY. So before we get into the PuTTY, I need to know the IP address of my Linux machine. And my IP address is right here. You'll see 192.168.1.20. So now if you see that 192 always comes up if you have the network adapter set as bridged adapter. And if you are connecting to the internet through wireless, make sure the name is connected to wireless, or if you are hard coded with the wire, then you pick the wire cable connection in the name. Anyway, so I know the IP address now. I'm gonna open up my putty session and I'm gonna put in my IP address 192.168.1.20, I believe. Let's confirm it one more time. Yes, it is 20. I'm gonna go ahead and click open. Log in as root. Okay, so I am logged in as root. I could confirm that I'm root, and also by the prompt right here, it says the prompt is pound. So I'm gonna make this a little bigger as well. So now let's say if I wanted to go to a website and I wanted to make sure if that website is up or not. So let's try our simple website as always, Google. Hit enter and you see all that stuff that came up on the screen. There's so much other stuff too. But you don't really need to worry about what that stuff is or how to decrypt that or how to understand the HTML to understand that. All you have to do if when you run the curl followed by the host name or the URL and you get this entire page with HTML coding and stuff like that, then it means that your website is up. You could reach it. Good. So if you wanted to ping it, so you could do ping www.google.com. This will only ping the IP address of the Google. You see the IP address of the Google right here, 216.58.217.68. So it could change. So you could ping it by the host name, which is google.com, which is URL, or you could ping by the IP address. So let's say if I ping it by IP address 216.58.217.68. You'll see you getting a response back, and that is Google. You could always do NS lookup on this to find out which website is that, and you will see this website belongs to these names, and these names translates to, which is the pointer record translates to Google. Anyway, what if you wanted to download a file from the internet using curl command? For that, you need to know the exact URL for the file that you're downloading. So I have on my browser, I have a page open which is download putty. So if you know, you could just go to, let's say, Google and type download putty. It will bring you to this page. Click on go to download, and you see right here, this is the .msi file which runs on Windows. We are not trying to download it on Unix or anywhere, but in Windows, then you could use this one. If you're trying to download on Linux, then you could use this one. Anyway, it doesn't really matter for this lesson because I'm just trying to explain to you how you could download it. So you could pick anyone. Let's say if I pick this one, right click on the link, and you see right here it says copy link address. Click on that. Once you copy it, you could verify the link by opening up your notepad, and then you could paste it here. You see this is the entire link for that tar.gzip file. Now go back to your putty session, and now this time type curl dash uppercase O and right click, which will paste your copied link to your screen. Once you have that, go ahead and enter, and you'll see it's downloading it. It tells you the statistics of the download. Now, is it downloaded? Where is it downloaded? Well, it will download whichever directory you are in. You are in /root. So we are in root, and let's say if we could verify, do ls-l, and you'll see right here, this is the file that we just downloaded today with today's date and time. So this is how you download if you don't have wget, or if you want to specifically download through the URL. These curl and ping commands are very useful. Also, a lot of people in interview would ask, tell me the commands or different ways that you could troubleshoot if a server A cannot reach server B, then you could simply mention that you're going to use the ping command, you're going to use the curl command. If it's a web URL, you're going to use different commands to check it. Also, going back to ping, if you're pinging Google, and you will notice that this is going to ping continuously. Now, sometimes if you are on Windows machine and you try ping Google, it will ping it 3 times and will stop. So to use that ping on a Windows machine, you would have to, I believe, use the option -S or -T, one of those options. So please try it. I'm very sure that it's one of the -T or -S option. I'm sorry, I don't have the exact option remembered right now, but try those so it will ping continuously, and you will see if the packets are dropped or if how long is taking for the ping to go and ping and come back. So these are the two basic commands that I wanted to cover with you. Try them out and just play around with it. All right.
File transfer. There are many commands that are used to transfer files from one computer to another. As long as your computer is connected on the network, you could transfer files or directories from one server to another. Some of those commands are FTP, which stands for File Transfer Protocol. This is one of the old legendary commands that are used in many different operating systems. It is still used in Linux, Windows, Mac, and many other operating systems. This command is used. Next one, we have SCP, which is a secure copy protocol, and then the next one is our sync command. This command is mostly used by system administrator to perform files backups from one system to another. They could schedule those commands through cron job to copy all those sync files. So let's look at a few of these commands in our Linux environment. Here we have our Linux machine, and I'm logged in as myself. So when you want to copy a file, let's say I want to copy a file that is called my first file, the first thing I have to do is type FTP and the machine name that it's going to, which is the destination server. Okay, so as an example, to FTP a file from your server to another server, I have logged in to my Linux machine as myself, and we'll see who we are. We are ourselves. So before you try to do a transfer, just see if you could ping Google, because without internet, you won't be able to transfer any file. Now, I could ping Google. It means my computer is on the network. Now, where do we have to transfer and what do we have to transfer? Now, of course, you do need a server that is running FTP daemon, meaning your server, you are a client, and the server that you're trying to connect should have FTP daemon running, and the daemon name is VSFTPD. For this training, we do not have an extra or external FTP, so we will try to connect to the Red Hat FTP server just for training purposes. So the command to run is FTP space ftp.redhat.com, and you will see as soon as you are connected, it will ask you for the password, for the username and a password. So you provide the credentials that are given to you by the Red Hat support. So when you enter the password and username, then you will enter the command put and the file name, and that's how it will be transferred to the FTP site. Now, if you're trying to transfer to a server that is not running the FTP daemon, so let's say in our environment we have ps-ef, and we'll grep for FTP, and you will see there is no FTP daemon running, right? So as as a training purpose, we'll try to transfer FTP to our own server, and our own server is local host, or the name of our host, which is my first Linux OS. So first, if you ping my first Linux OS, you'll see you are getting a reply back, right? So it means you are connected to your own machine, of course. Let's clear it out. And now try to do FTP my first Linux OS. And as you hit enter, you will see it says connect, FTP connect connection refused. And why is that? Because my server or my Linux machine is not running the daemon, and the daemon is the one that listens to the incoming traffic. So anyway, this is how you run the FTP command and you transfer the files. And again, the purpose of doing FTP is if you have an issue with your system and you're troubleshooting it and you involve support, whether it's Red Hat or CentOS or Windows or whatever the support that you have involved, they would ask you to send the logs. And they will give you the FTP server, account information, and credentials. So you would have to run FTP command to send the logs over. The other command that we wanted to cover is SCP. Now, SCP is basically copying a file from one machine to another, and of course it has S in front of it, so it means it's copying it securely. So let's take an example of a file that we want to transfer. Let's see which directory we are in. We are in our home directory, and let's say I have a file called right here La La Land. So I want to take this file, copy it from machine A to machine B. Now, of course, we don't have machine B where we want to transfer. So we will use our own machine and pretend that it's a remote machine. So the way it works is we'll do SCP La La Land, which is the file that I'm trying to copy over. So where am I trying to copy over? I'm trying to copy over to another machine, remote machine. So we are pretending the remote machine is, which is our own machine, of course, my first Linux OS, and then you put colon, which is first is the host name, slash where are you copying it to. So let's say I wanted to copy it to my home, my user directory, and the directory I want to copy it to, let's say Seinfeld. Seinfeld is the directory I wanted to copy that file into that folder. So once you have that command, hit enter, and it says could not resolve hostname my first Linux OS. Oh yeah, because I have misspelled first. These are the type of things that you probably would have to troubleshoot. You hit enter. My first Linux OS. It's still not coming up. So what we do is we'll just take out this part. So I'm just gonna, what I'm gonna do is I'm gonna copy this and I'm gonna paste it and then hit enter. Okay, so it is saying that connect to host my first Linux OS port 22 connection refused. So it is refusing a connection. Why is it refusing? I'm not sure, but let's try to do localhost. Yes, so you put in the password, of course your own password, because you are logging in as yourself on the other machine as well. This is your own password. So once you put in the password, you will see it says La La Land 100% completed 7 bytes, and the rate, and it's 0.5 kilobyte per second. This is the amount of time it took to transfer. So it did transfer. So now let's verify if Seinfeld directory has that La La Land file in it. So which directory I'm in? I'm in home IFZL. Let's go to Seinfeld, and now ls do ls-ltr, and you'll see, yep, right here it says La La Land. There you go. Just to confirm, let's say etc host my first Linux OS. So it has 192.168.1.14. Okay, so now I know. So this one, I have hard coded my host name with 192.168.1.14. And I'm sure why it didn't work, because my IP has probably changed by now. So it's probably hitting some other device in my network. And you see, yes, it now my Linux machine is 1.13. And the reason I was not able to connect, because 1.14 is probably one of my other laptop or my iPad or some other device in my home network that got that .14 IP. And when I ran the scp command, it was actually going to that device. Perfect. It was a very good example. Now you guys learn as well that how important the etc file host file is. I'll go ahead and modify that. I'll become root, and I'll do vi etc host, and I'll just take these two entries out. I'll just leave these two and close. So now if you run that command that we were trying to run before, hit up arrow key. No, sorry, we were as logged in as ourselves, right? So now when you run that command, you will see it will give us a prompt. There you go. See, right? This was the one, right? You hit enter. See, it's connected. The next one is rsync, and this will tell you exactly, if I just type rsync, it'll tell you how you could copy files. If you just want to itemize the changes, it will also tell you the progress of it. So this command is used, it's a very famous command now, and it is used by many system engineers to do and to perform file systems backup.
Hello, in this lesson we are going to cover SCP, which is Secure Copy Protocol. Now the Secure Copy Protocol, or SCP, helps to transfer computer files securely from a local host to a remote host. It is somewhat similar to FTP, but it adds security and authentication. So if you are transferring a file again from server A to server B, you could use SCP as the protocol or the command rather than FTP, and the reason it is preferred is because it is secure. It adds more security and authentication. Now the protocol, as I said before, the protocol is a set of rules used by computers to communicate. So when the SCP was built, they decided, okay, this is the protocol that SCP should use, and this is the port that should be used to transfer a file from one server to another. The default SCP port is SSH, or port 22. So there is no different protocol that was established or set up for SCP. So it actually leverages onto the same SSH protocol that we use to connect from one server to another over SSH. Now, for this lecture, again, we needed two Linux machines. One is for the client and one is for the server. The client is where we have the file, and the server is where we want to transfer that file to. For the client, I have my Linux machine, and it is called my first Linux VM. For the server, I have a server which is exactly the same as client as well, but I named it Linux CentOS 7. So the process is the SCP. The process in the graphical way is you have a client A and client B server. Now client A wants to copy a file over to server B. Now it will use the protocol SCP or the command SCP, but it actually transferred that over through the protocol we already have in place, and that is SSH. So there is no new protocol for that. It actually piggyback on SSH. And of course the SSH port is 22, and the service for SSH daemon should be running on the recipient or the remote server in order to accept incoming traffic. Okay, what's the process? The SCP command to transfer files to the remote server. First of all, you have to log in yourself. Then create a file, any file. Let's say we in this lesson or in this lab, we'll create a file called Jack. Once the Jack file is created, then we will simply run the command scp, the file name Jack. IFZOL is the username that actually exists on the remote server. At 192.168.1.x is the app actual IP of the remote server. Of course, replace that X with the digit. That is the digit of your remote server. And the last part is :/home/ifzol. This is where you want the file to go to in this directory on the remote server. Once it's connected, then it's going to ask you to enter username and password, and it will transfer the file successfully. Now, enough is enough. Let's actually start our Linux machine, which I have already started, and I have already logged in through my PuTTY. This is my Linux machine, and I refer to as my client machine because this is the one that connects to the server. And this machine host name is my first Linux VM. Who is logged in? Who am I? I'm logged in as myself. If I follow the directions here, I'm going to create a file called Jack in my home directory, /home/ifzol. I'll go ahead and do touch Jack. And I do ls-ltr, you will see I have a file called Jack. It has 0 bytes. Now, I want to transfer that, but before I transfer, let's put something in there just to make sure it is transferred with the right content. So let's do vi on Jack and just put Jack is Jerry's uncle. That's it. Do ls-ltr. Now you see it has total bytes 22. Perfect. Now we need to transfer this file to our remote server. But before we transfer that file to the remote server, we wanted to know what is the IP address of that remote server. So I'm going to go into my remote server, which I also have it opened. And I'm going to do ifconfig enp0s3 because that's the interface where the IP is assigned, and the IP is 192.168.1.58. Beautiful. Let's go back to my client, and now this time I'm going to run the command. Let's clear the screen so you could see it better. Now run the command scp, the name of the file, which is Jack, the name of the user who is going to log in to the remote server. What is a remote server? 192.168.1.58. Yes. And then : / where is it going to, or which directory? It's going to home ifzol. Hit enter, and it's going to ask you for the password. If you are doing SCP for the first time, then it's going to ask you for the fingerprints, where you have to type in yes and then enter the password. So go ahead and enter password, and it says a Jack, which is a file name, 100% transferred, and the size was 22, and this is the time it took to transfer. Okay, I got this message on the client, but let's confirm on the server whether it was transferred or not. So first of all, it was transferred as ifzol, so I have to log in as ifzol. So who am I? I am ifzol. Beautiful. Now, which directory am I logged into? I am in my home directory because that's where I transferred the file, right? Now I will do ls-ltr to check if that Jack file came in. It did. Perfect. Now, is this the right file that came in? Let's cat it. We did the cat. Jack is Jerry's uncle. Perfect. This is how the SCP works. And you could also do the same thing, by the way, SCP to go into this remote server if you wanted to pull something out of that server from server to the client, and you just have to reverse the command. Anyway, try it out, and these are the couple of commands, a few commands that I wanted to cover, and very important commands when you are dealing with transferring files from one server to another. Hello, In this lesson, we are going to look into rsync. Yes, another utility to transfer files from one machine to another or copy from one machine to another. And then rsync stands for remote synchronization. What exactly rsync is? It's a utility for efficiently transferring and synchronizing files within the same computer or to a remote computer by comparing the modification times and size of the files. So basically transferring file from server A to server B. And the way it works efficiently is because it looks at the modification times and the sizes. If the size is, let's suppose 2 gig, it will transfer the first time 2 gig. If the second time is 4 gig, it will only transfer the change, which is 2 gig, not the entire 4 gig. I'll tell you a little bit more about it. Now, the rsync is a lot faster than those tools like FTP or SCP. This utility is mostly used for the backup of files and directories from one server to another. A lot of system administrators and engineers actually have rsync command or utility running in the cron tab to actually copy files, everyday files or modified files from one server to another as a purpose to back them up. The default rsync port is 22, which is the same as SSH that SSH uses. So there is no rsync server that you need to install on the remote server to accept the incoming traffic. It is going to use the SSH protocol. Just like SCP uses the same protocol SSH, rsync does the same thing. So it piggybacks on port 22 SSH. For this lecture, again, we need 2 Linux machine because we need to test from copying or synchronizing files from one server to another. I have my first machine is my first Linux VM, which is I refer to as client because I transfer files from that machine to another. And what is another machine is my server, which I created another CentOS VM, and I named it Linux CentOS 7. It has the same specification as the first machine that I created. Nothing changed. The only thing changed is the host name. All right, let's look at more in a graphical or in a diagram way, so I'll make you understand how the rsync utility works. So you have a server A or client that needs to go to server B, and it needs to transfer those files over the utility rsync. Now, rsync uses SSH or piggyback over SSH to transfer the files. And for that, you need SSHD service running on the destination server where the files are going, and the port by default for SSHD is 22. Now, what it does, the rsync, it actually copies and copies to destination, keep the same copy, the same size and the time from source to destination. How it works? Let me show you right now. If you have a 2 meg, the size of the file is 2 meg of a file. It transferred the very first time the exact same size 2 meg. Next time someone comes in and change that file, now the file size become from 2 meg to 8 meg. So now you need to transfer this file from server A to server B. So now this is the beauty of rsync. It is not going to take your entire 8 meg and copy it over again. It will actually subtract those 2 meg that was copied earlier and only copy the one at the difference in the file, which is 6 meg. And then ultimately the first half or the first 2 meg plus the 6 meg, it's going to combine them together to make it 8 meg. Similarly, if the file grows from 8 meg to 20 meg, the rsync will subtract the difference and only transfer the difference over to the destination server. All right, let's look into the technical side, how the command works. So basic syntax of rsync command is rsync space the option if you want to specify any option, then the source, what are you copying or transferring, destination, where are you copying and which location. Install rsync in your Linux machine. So first thing we need to do is, if rsync is not already installed or the command is not available, we have to install that utility. But first, before you go ahead and install, check if it is already installed. So if it's not, do yum install rsync and CentOS Red Hat distribution in Ubuntu Debian. You do apt-get installs rsync, then rsync a file on a local machine. So you need to copy a file from local machine. Within local machine, you need to do, let's say if you wanted to tar, so for that, let's create a backup of the entire home directory, and we put in a tar and then we back it up. We'll rsync a directory on a local machine. We'll rsync a file to a remote machine, and we'll rsync a file from the remote machine. All right, so these are the steps we will take. So I know it's a lot of information throwing at you, but we'll try one by one, and I'm sure you'll understand by the time we're done with this lecture. So I have my Linux machine open. This is my Linux machine, which is my client and which is my first Linux VM. Oops. Okay. Now what I need to do is I need to make sure I have the rsync package installed. Before I actually go in and do yum install, let's do rpm-qa and grep for rsync. Beautiful, it is there. By the way, I am logged in as myself, and again my host name is my first Linux VM. And to check if the package is installed or not, you don't need to be root. You could just simply run rpm-qa. But if you need to install a package, then yes, then you need to run yum install rsync with the root credentials. All right, now we have confirmed that we do have rsync package. Now let's get into the fun part, where we're gonna do the rsync a file on a local machine. So I am in my home directory, and I do ls-ltr, you see all these directories and files. What I wanted to do is I wanted to put all these directories and files into a tar file, into a container and tar it. So for that I'll do tar cvf backup. This is the name I wanted to give once it's archived and tarred. And what I'm tarring everything within the same directory. And this is the same directory, which is pwd. When I did it, it's home ifzol. So that's why I'm using dot. I could have used /home/ifzol as well. But since I'm already in this directory, no need to specify the absolute path. Go ahead and hit enter. All right, so it has tarred all the files and directories into backup.tar. You see it is there. Perfect. Now I'm going to use the rsync utility to rsync this backup.tar into another directory, and that another directory I'm picking is /temp/backups. So before I do that, I wanted to create that backup directory, which I don't have it created yet. So I'll do mkdir /temp/backups. Perfect. It is created. To test, you could do cd/temp/backup, and there you go. It is. And you are in /temp/backups. That's how you confirm it. Anyway, you cd back out, do pwd just to make sure you are in your home directory. Yes. Now let's run the command rsync -zvh. If you wanted to know every little detail about each of these options that I'm using, then you should run the command man rsync, and it will give you the information about every option that is available to you. Here are the different options. Anyway, rsync -zvh backup, which is the file name that we created, and backing up where? It's going to tell me temp backups /temp/backups. Go ahead and hit enter. There you go. It's sent. It says 1.06 bytes received, 35 byte size, and it took 754 bytes per second. It's a transfer speed. So now go to cd temp/backups and check, verify if the backup.tar file came through or not. Let's do ls-ltr. It is there. Nice. Okay. Now, next thing we wanted to do here, let me move this up or on the side. Right here, sync a directory on a local machine. So before we synced the file, now I want to sync a directory. So let me go back into my home directory by just typing cd and hitting enter. Now do pwd, you're going to see it's home, ifzol. Do ls-ltr to see the content inside of my directory. Now again, you probably have a lot of different files in your home directory that you might not see on my screen, because I make a lot of changes when I go through making videos. So don't worry about it if my contents don't match with your contents. Okay, so rsync a directory. So to do that, I want to rsync everything that I have in this directory to this temp backup directories. For that, I will use the command rsync -azvh /home /ifzol. Perfect. And let me move this up. And I'll put this window right here so you know exactly where I am. Okay, and now where I am copying it to /temp /backups. Hit enter. Bingo. Beautiful. It works. So let's go to temp.backup. Verify everything that I have in my home directory, which is /home /ifzol. You notice everything has been synchronized here. Perfect. Now let's talk about the part right here. Let's move it down. It says rsync a file to a remote machine now. Now for my remote machine, I have this as my remote machine, and I call it Linux CentOS. And the IP address for this remote machine is ifconfig enp0s3. It is 192.168.1.58. This is the IP address, and this is where I want to transfer. So let's minimize again. So I'll go into my home directory, and I want to copy or rsync the backup.tar file. Now before I rsync this over to the remote server, I want to create the destination folder where this is going to go. So I will go back into my server, and I'll go into /temp, and here I will create a directory called backups ls-ltr, and you're going to see right here at the bottom it has been created. Let's clear the screen. Now let's go back to our client machine. This is our client machine. Now we're going to use the command rsync -avz backup. That's the file we wanted to transfer over. Now you want to transfer over as what user? As myself. Okay, which machine is it going to? It's going to 192.168.1.58, which is the IP address we just checked on our remote server. And which directory it's going to? :/temp/backups. This is the directory it's going to. Go ahead, hit enter. It's going to ask you for the password for the ifzol on the remote machine. Put in the password. Beautiful. It is transferred. It says sent. It tells you a lot of information and speed and everything. Now once it's transferred, it's your job to verify it has been transferred. Go to your cd/temp/backup directory, do ls-ltr, and you'll see right here this is the one that's been transferred. Perfect. Let's move on. Let me minimize this. Now the last part is right here at the bottom. It says rsync a file from a remote machine. Now we want to go to the remote machine and fetch a file from there. So which file are we fetching? So first let's make a test file, a dummy file. So I'll go into my home directory because on the server I'm logged in as myself. Here I'm going to create a file. I'm going to call it server file. Do ls-ltr, and you're going to see the server file is there. Perfect. Now if I come to my client machine, to pwd, and do ls-ltr, you see I don't have that server file. So I need to bring or pull that server file from the server. And for that, I will have to do rsync -avzh ifzol, because this is the username I will use to log into the remote host. What is the IP of the remote host? 58. Perfect. Now, where is that file that you are trying to bring? The file is in home ifzol and the file name is server file. Perfect. Now when you bring it, where do you want to save it or copy it to? I want to copy it to my temp backups file or directory. Go ahead and hit enter. It's going to ask you for the password. Perfect. It says sent 43 bytes. Now where did it go? Let's verify it. I ask it to come to my /temp/backup directory. Do ls-ltr and you're gonna see right here it says server file. See, that's how you fetch a file from the server. So anyway, there are different options that are available on rsync that allows you to do like dry runs, allows you to do rsync continuously, allows you to do only deltas, meaning only the changes. You just need to pick the right option to use, which option works for your own requirement. Good luck. SSH and Telnet. These are the two main services that run in Linux to accept connections from outside. Telnet is an old and unsecure connection between two computers, and a lot of companies don't use Telnet anymore. The SSH is the newer connection established protocol that is completely secure. There are two types of packages for most of the services that you see on a Linux machine. One is a client package and the other one is a server package. So you have a server, it sends a connection request, an SSH request to another server. So in this case, you are the client and the computer you're trying to connect is a server. So let's take it the other way. So if you on the right hand side and the server is on the right hand side, when it tries to sync its time to you as in through the NTP protocol, then it's no longer the server, it becomes a client, and then you become the server. So let's look at our SSH and Telnet, both of these little services that we have and how they work in our computer. I will connect it through the PuTTY session and I'll confirm I am root. Let's clear the screen. And the service that runs, the first one is Telnet. So when you run Telnet, you'll see it says command not found. Why? Because by default now Linux don't include Telnet in the installation. So if you have to install Telnet, you would have to do yum install Telnet, and it will go to the repositories and it will match the option I have for Telnet, and it found one package and it's telling me, do you want to download? Now we will not be using Telnet in our environment, but if you are troubleshooting, Telnet is sometimes a tool that allows you to troubleshoot some of the network communication issues. But for this lesson, we'll just skip that and we don't want to download that. Next one, we have the SSH. Do we have SSH? Yes, we do. That's why we got this usage of SSH. We could do SSH2 followed by the IP address of the remote computer. But since we don't have a remote computer, we'll just say local computer, which is the same box that we are already logged into. When you do hit enter, yes, you're logging in as root, so put in the root password and you logged into the same machine that you were logged in before. So you could create as many sessions as you want. So you could exit out and you'll come back to your first session. To check the service of SSHD, we'll run psef to see if the process is running. And you'll see the process is right here. It says user sbin sshd. This is the process that actually listening for all the incoming traffic. If I stop this process, I will not be able
to log into this machine anymore. But before we do that, I wanted to check my IP. And my IP address is 192.168.1.12. And let's go ahead and stop the SSHD service. When you hit enter, you get the prompt back. It means it's not running. You could do PS-EF again to grep it. And you will see the SSHD and SSHD. This is this already established connections that's telling me. But it is not showing the one we looked for before, which is user SBIN SSHD. So it means it will not accept any incoming sessions anymore. How can we confirm that? Let's log into a new PuTTY session, and I will put in the IP address of this machine again, 192.168.1.12. See, it says network error, connection refused, because there is no SSH daemon that is running. So we'll click OK, close this out, and this time we'll start the SSHD process. It is started because we've got a prompt back. How do we verify it? You could run PS-EF again, SSHD, and you'll see right here the process is running now. Now it will accept the connection. Another way to find out if that service is running is by doing system CTL status SSHD, and right here it's telling you active, and running. So now if you try to connect to that IP 192.168.1.12, you should be able to. 192.168.1.12. Bingo. You see how SSHD works? So this is how you could stop the connection to your server or refine or restrict your computer. This is a way to an enhanced way to implement security on your system. Host name and IP address lookup. What exactly that means is if you have the host name and you want to find the IP address, how does it work? We do have DNS, right? And there are protocols that we run like ping, or we go to a browser and we type in the host name or the website name, and it resolves to an IP itself, because those are the type of protocols that knows that it needs to resolve IP address first. If you don't have those protocols and you just wanted to know the IP or host name, then you will just run the commands like nslookup and dig. There are two major commands or tools that are given to us in Linux. I believe they are also available in Windows. I'm sure nslookup is, but I'm not sure dig is available. But you could also dig for dig to find out if dig is available in Windows. So what exactly these tools or these commands do for us? Again, they resolve hostname to IP, IP to IP, or hostname to hostname. Let's look at them by logging into our system. I'm logged in through the console, and the command I will run is nslookup. When you run this, it will bring me to its own menu. And if I type here www.google.com, it is giving me the IP address of Google. What is right here? Right here is our resolver, meaning this is our DNS server. Our DNS server, since we are running our machine local to our modem, so our modem is our DNS server. And our modem is also accepting requests for DNS, and DNS port runs on port 53. And when you see the message here, non-authoritative answer, it means that when I typed nslookup for that IP, my modem does not have the information for that google.com. It went outside on the internet to find that information for me. That is why you see that here, non-authoritative. If I had the information for Google saved in my local computer or in my local DNS server, then I would not have seen non-authoritative answer. I would have gotten the straight name and address. So you could quit out of it or control C out of it, clear the screen. So you could also run nslookup, just simply followed by www. Let's say this time we'll do hotmail.com. And you will see the Hotmail IP address is right here, 204.79.197.212. If you type this IP address into the Linux machine or in your Windows machine, you will get the page that's associated with this IP address. Similarly, the same command works for dig, hotmail.com, and you will get the same answer, but a little differently. So some people use nslookup and some people use dig. Nowadays, a lot of people uses and more inclined toward dig command as compared to nslookup. nslookup is a very old utility, and you could get a lot more information out of dig command as compared to nslookup. So try nslookup or dig command on different websites like www.facebook.com, and then try to see if you could get this IP and resolve it to the page that you're going to. So in our example, we could try to open up our server right here. Our browser. And in this browser, let's close some of the tabs. In this browser, I will type the IP address that shows up for Facebook, which is 31.13.71.36. You hit enter. You see, it took us to the Facebook. Page. That's how the internet DNS works. It does not know the name. It only knows the IP addresses. But since we are humans, we tend to remember the names instead of IP or digits. That's why it's become easier for us to use DNS that actually translates hostname to IP address. So try these two commands a few times. Do run man command on them and see how it works. NTP, this is the second service that we wanted to learn, and this service stands for Network Time Protocol. The purpose of this service is to synchronize your computer's time to another server in case you lose your time drifts from seconds to minutes, and when you are running a few servers, more than one, in a clustered environment, and you're running your workflow. So in corporate environment, it becomes very, very imperative that you have all your servers synchronized with one clock so the time won't shift. So the file that we will be configuring for NTP, it is etcntp.conf. The service to run the NTP daemon is systemctl start or restart NTP daemon. And the command to check whether it is synchronized or not, we will have the command NTP running. So let's get into our server and we will do some configuration, or if the configuration is already there, we'll go over it and we'll restart the service. This is our Linux machine and we are logged in as root. And the first thing we have to do is check whether the NTP package is installed or not. So you'll run the command rpm-qa and type NTP. Alright, it's telling you that I do have the NTP package installed. If you do not have this package installed, then you could just run yum install NTP And of course, you will get the option to hit Y because it will tell you these are the packages it found, and this is the size of the package. Do you want me to install it? And you'll hit Y and it will install it for you. Since I already have installed, it's telling me already installed and with the latest version. So let's move on. The next thing you would do is to modify the ntp.conf file. ntp.conf file has all those comments that starts with #, so just ignore them. Go to the line that has server. Now in my configuration, I have previously selected the server 8.8.8.8. This server resolves to what? If anyone knows, any guesses, this server resolves to Google. It is a Google DNS server. This is configured to provide your DNS resolutions, as well as sometimes people use it for network time protocols. So I have set it up 8.88, and that's what I'm going to use it. The other ones are the CentOS predefined. I'm not going to touch them, and that's it. I'm just going to save it. If you don't have it set up, I want you to set it up as 8.888 and then save your file. Once the file is saved, run the command systemctl and start your service. And the service name is ntpd. And D again stands for daemon. Daemon is a service that would never stop and just keep running as a process in the background to listens to the request that comes in. How do we know we have started the service? You do status, and right here it's telling you that NTP service is running. Good. So another way to find out whether the service is running is ps-ef command and grep for NTP. Here you will see this line telling you the NTP server is running and the process ID is 4340. You could kill that command by typing kill 4340. NTPQ is the command that will bring you to an interactive mode. When you hit enter, you type peers, and it will tell you which servers you are connected to get your time. You are getting your time from Google. This is the first server. If you remember, we just configured it with 8.8.8.8, and that is the Google server. We're getting our time from it. The other ones are CentOS servers. So we have confirmed it is getting its time. Now we'll just quit out of it. And if you wanted to stop the service, we'll just do stop, and it has stopped. And if you want to verify it, you'll see there's nothing in there. So NTP is another one of the service that every system administrator should know, and it is very imperative that all your workflow servers should run NTP to have time synchronized between them. So try this NTP with different servers and have fun. cronid. Now cronid is a daemon that is the latest version that is used nowadays to replace an NTP daemon. Now why did they do it? Because it probably have most enhanced features in it, so we'll cover that cronid in this lesson. So the purpose of cronid is again for time synchronization, exactly the same way as NTP that we had covered before. The package name that you would need to install for this program is called cronid. The configuration file is etc/cronid.conf file. This is where you go in and specify the NTP server. Now again, NTP is used to synchronize your system clock with an external clock or any other clock within your organization that serves as an NTP server. Then we have a log file for cronid daemon, and that log file, all the recording or all the activity is logged into var log cronid directory. And then we have a service, of course. When you configure the cronid.conf file, then you have to start or restart a cronid service. And by now you should be familiar, it's systemctl start cronid. And the program command that you could run at cronid C, which will tell you which NTP clock you are synced with, what's the status of it. So let's look at our Linux machine again, and we'll try out this new feature, this new program that is used in Red Hat and CentOS. Okay, so I have logged in as myself to our Linux machine, and of course through console, see who we are. We are ourself. Which host are we on? We are on our correct host machine. Now I want you to become root. Okay, now check if we have the package, and the package name is cronny d. So it's rpm minus qa. Again, rpm is script that will list all the programs that we have with the minus option q and a, and we'll grep for cronny d. And when you hit enter, I think it's just like cronny, I believe, not with d. Yes. Okay, so I have confirmed that I do have the cronny d package, sorry, cronny package, of course. Now, what's the next step we always do once we have the package installed? We configure it, right? So let's go into our configuration file, which is etc cronny.com file. Hit enter. And this configuration file pretty much looks the same as ntp.conf file. And we will have to go to the line where it says server. This is where you define your NTP server. And as you see, the first server, second, third, there are 4 servers that are automatically defined. And these are the actual servers. Set it up by CentOS. Let's put a new line, and I'm gonna have this server as pool.ntp.org. Now this is also one of the server. So you know what? Just as for giggles, we just sync it with Google 8.8.8. So of course, this is not an NTP server by Google. This is just a DNS server, but just for practice and training purposes, I'm just putting that in. So this way, when we check the status, we'll see it is connecting to the Google. Anyway, you escape out of it and do write and quit. Now you saved it. Now the next step is you have to start the service. So to start the service, first check if the service is running. System ctl status cronny d, and it says right here, it says inactive. Okay, so we have to make it active. But also one thing I wanted to mention, that please do not run NTP and cronny d at the same time. So check the status of NTP as well. Sorry, NTPD, and if it is running, I recommend you to stop it. So it is running, as you could see here, right here, it says active. So let's stop it, because we don't want to run 2 services that performs or that serves the same purpose. So let's do status and stop. Now it has stopped the NTP, just verify it. And it says inactive, right? Okay, good. Now also I wanted to disable it so it does not get started at the boot time. So disable, and now it is disabled. Now I could go ahead and do system ctl start cronny d. Okay, it is started. Let's check the status. Okay, it is active. Okay, now we have to enable it so it gets started at boot time. It is enabled now. Okay, so now the program that comes with this package, it's called cronny dc. So it's cronny space and then c of, I think it stands for command. So we'll run cronny c, And when you hit enter, it will bring you into an interactive mode, a program mode of its own cronny. Cronny C. So now when you type help, you'll see there's so many commands that you could run within this program. But the one that I wanted to run, it's called sources. So this will tell us, where did it go? Right here. So this will tell us which NTP server we are connecting to. So I'll type this command. So while I'm in cronny C, so it's sources, hit enter, and you will see right here the first one, if you guys remember, that I picked 8.8.8.8. so this is the Google server that we are syncing our time to, and of course this is not actually an NTP server. I just picked it for training purposes, so you could exit out of it. I think it's quit, and I will go ahead and modify my cronny.com file again, and I will remove this first line. Once it's removed, this way I'm not hitting Google and DNS server for some different purpose. Anyway, so now it's modified, removed, and now do restart on the service, because we just modified the configuration file. Every time you modify a configuration file, you have to restart its service. Now run this cronny C again, and now you do sources, and you will see now it's going to a different server which is defined in there, depending on what is it resolving to. So that's the topic about cronny D. Again, it's a replacement for NTP. It has newer features. You can look it up online, what are the newer features and what's the difference between NTP and cronny D.
Trace route. Trace the network traffic. So in this lesson, we are actually going to learn and try to understand how we could troubleshoot the network issues if we are having any network issue in our environment. And one of the commands that is mostly used to see where your traffic is going, which gateway or which DNS server it's going from one to another to the third, and finally how is it going to reach its destination. And to view that entire tracing of those network traffic, you have to use the command trace route. And this is the command, I believe it is also available in other operating systems as well. In Windows, I believe it's called trace RT. I'm not sure exactly what is the command in Mac or other operating system. Anyway, our focus is Linux, so let's see what traceroute does. The traceroute command is used in Linux to map the journey that a packet of information undertakes from its source to its destination. One use of traceroute is to locate when data loss occurs throughout a network, which would signify a node that's down. So as it says, we just need to find the tracing from source to destination, how the packet went through from one to another. Because each hop in the record reflects a new server or router between the originating PC and the intended target. Reviewing the results of traceroute scan also lets you identify slow points that may adversely affect your network traffic. So it could be many different PCs or many different machines or gateways in the middle while your traffic is flowing that could affect your traffic flow. And that's how, once you know, hey, I know this is the machine that is the troubled machine that is causing my network traffic to fail, you could find that out by running the command trace route. Now the command itself is just simple trace route and the destination hostname or the IP address or the URL in this case. So if you are trying to go to a URL, let's say google.com, hotmail.com, facebook.com, or wherever you are going, or if you are in your local environment in your corporate world, you probably have an IP or a host name of your machine. Then you could run traceroute space the host name, as long as your machine or where you are running the traceroute can resolve that host name to IP. If it cannot, then make sure you put in the IP address. Okay, let's get into my Linux machine, and then we will try this traceroute command on it and see how it works. So I will go into my console, and first thing I want to make sure I am online, so I could just do ping any website. So you'll see I'm getting a response back. So I am online. So now let's run the command trace route. Now, when you run it, you have to specify the host name if you are in your environment, in a corporate environment, and you are running your infrastructure, and you probably have a lot of servers, so you have to specify the host name if it could resolve it, otherwise the IP address. But for us, since we are using the lab environment, we'll just do google.com and hit enter. And you will see the first hop it is going to do is it's going to jump on to our modem. This is my modem, which is also a gateway to my traffic. So the first hop it is doing is going to my modem, and this is the time it takes to go there, and it didn't cause any issue. If there was any um, hang time there, it will tell you this is going to take that much long time to go to the second hop. Second hop is going to another gateway right here, which is most likely my NATed IP, which is the internet IP address, or the internet IP, the gateway IP, and then it will tell you it did 1, 2, all the way through the 14 hops to get to this IP address, which is the resolved IP address of the google.com. So this is how you could actually use the traceroute utility to find out how your traffic flows from your source to the destination. The reason it went to my gateway first is because that's how my gateway is defined, and to find out your gateway you could run the command netstat minus rnv, and you will see the gateway I have for all my traffic should flow from the gateway 192.168.1.1. It might be different in your environment depending which environment you're working on, whether you are doing this lesson through your work, then you will have a different one. If you are doing from home, then most likely you will have the same IP address of your gateway. So this is about the trace route. Try to find it, how you could troubleshoot. Many times people also ask what are the different ways you could troubleshoot networking related issue in the operating system. So you could also bring up this trace route command, and this is one of the uh, main command that will help you troubleshoot networking related issues.